But please do have a look at those videos so you'll get a feel of the style of videos which Amrit and Anshuman make, and also the kind of storytelling that they adopt, and that is the primary focus of the workshop. Just a very quick housekeeping. The housekeeping is that we'll be circulating a sheet of paper for the external participants. This is to get the details for issuing you the e-certificates for attendance in the 2-day workshop, and also to show that you are a winner of the national webinar competition. So please do fill in the details. You can also fill in the name of your institution to help us. So yeah, that's it basically, and I now give the floor to Amrit and Anshuman. Thank you very much. And website is being activated as we speak. Somebody from the IT wing is coming. They will activate it as soon as possible. Thank you.
So we shall start, or shall we wait for more people to show up?
Let's start.
Okay.
Because the time was 9, we slightly delayed. You can go ahead.
Okay.
Yeah.
All right. We welcome everybody for this workshop on improving your storytelling / communication for when you talk about your research. And a lot of it is about you doing things with us using a framework we'll talk about. There are many frameworks. We have picked up something. The important thing is that we today look at a baseline pitch that we have and improve it, so that in the next half when you actually present, you make use of the few things that we learned today. That's the broad objective. With that, so Anshuman and I, we run a storytelling consultancy, but as part of what we do, one of the projects is with IIT Madras. We came up with this idea that if we put together professors from different departments and labs to explain their latest publication to each other, how would that be? So we were forcing a professor to sort of realize that, the mechanical professor has to realize that the computer science professor is still a professor, but might not understand a lot of terms and things like that. So we are forcing them to change their pitch in a way that they understand it, and likewise. And yet we are telling them that we will make a YouTube video of that and put it out. So then your audience is both a professor, but then could be a science student. Don't dumb it down to extremely total mainstream bit, so keep it technical. But it was a fun challenge for most professors. We have been doing it since January. There are 4 things that we have observed while looking at professors trying to explain this. And this is not usual for most of you, right? You go to your conferences where you meet folks who are from your domain, so it becomes a little challenging to sit with a professor from a different department and talk about your publication. It's not easy, and we have seen a bunch of different flavors.
Before that, please like, share and subscribe to the channel. This is the QR code. This is a link to the channel. You can check it out later, watch the videos.
So first thing that we have seen is a time traveler approach, where the professor starts all the way from the very beginning since the grant was approved, then the third research that happened 3 years back, then the limitation of that one, followed by, so what happens is they know that, especially in this case, we have 3 professors, so we tell that if each of you take half an hour, then this round table is not going anywhere. So you broadly communicate this. So a time traveler approach comes in the way. It's a chronological approach to narrate your pitch. Nothing against it. There might be many occasions when that is the perfect approach. However, we have seen, especially when I ask you to do it in 2 minutes, 10 minutes, 5 minutes, it's possible that there are better approaches. So that's the one point that we want to make. We'll take you through that.
The second one is the encyclopedia, where because you know too much, you keep building the background, and the main point either never comes up or comes up a bit too late. So too much of background, you keep building, and by the time you have lost the audience. Next one.
Then obviously most of you will relate, because if you are used to talking about all the technical terms of your research, which has, for others it's a jargon, if the other person listening to your paper doesn't understand the particular technical term you threw at them, or you were not able to explain it properly, then they obviously can't follow your research. So we have seen a variety. Some professors, for some reason, have figured out how to explain a technical term from their domain. Others feel it is too important to mention it, so they still throw in that jargon. And again, the issue is that following that research, it's technically absolutely correct. If somebody records that session, goes to AI or things like that, they will eventually figure it out. But when listening to that pitch, you simply cannot follow because you don't know that particular technical jargon. So that is what we have observed many times. It's difficult. We'll tell you today a way to navigate this particular aspect without dumbing down your research. There are ways to solve for this.
How much we are cribbing about professors, I'm glad they don't grade us anymore. The next one is the hedge maze. So I remember someone yesterday said that when the professors are being careful, when I think this was during PK's presentation. So this is exactly that point. While they are trying to explain their research, because they know a lot and they try to be absolutely technically correct, they throw in too many caveats before the main points. And so this point talks about that. And in corporate, they say that humility is a good virtue. I think in academics, they need to tell you that too much humility is also not a good virtue. So this point is about that.
So did we show the workflow? Yeah, so I think I forgot to say that. So we are, before tea break, 3 things that we do. We start with a bad presentation. So we will, for all those 4 things that we just mentioned, Anshuman will try to be that professor who is going to be like an encyclopedia, going to throw in a lot of jargons, narrate everything in a chronological fashion. And what is the other thing? There's one more thing, right? We will see. So, and after that, we'll probably take a poll. Like we have tried to figure out how bad can you really make where nobody can follow anything and yet everything actually is technically correct. So, and we'll try to do it in 2-3 minutes. So the idea is after this bad presentation, we will make the same presentation after maybe 10 minutes where we talk about some playbook so that it's not just theory. You can see that if we just implement few things, these are mostly what we said is not to be done. We will also talk about what to be done, right? So we have spoken about 4 things not to do. Do not always speak everything chronological. Do not never throw jargon at somebody who doesn't know your jargon. Don't be an encyclopedia, and don't have to put so many caveats if, but, then, because you are not being rated by your peer who will say that why did you. They are trying to explain broadly your research. But if we do that, then what happens? Let's have a demo right away.
Hi, good morning everyone. I am going to explain my paper which is titled A Quasi-Isodynamic Stellarator Configuration Towards a Fusion Power Plant. So, stellarators generate rotational transform largely through external 3D coils. Unlike...
That's part of bad presentation?
Mics always act up even in presentations. Yeah. So unlike axisymmetric tokamaks, generic 3D stellarators lack this symmetry that naturally constrains collisionless particle orbits. Okay. Omnigeneity aims to make the bounce averaged radial drift of trapped particles vanish. Practical designs only approximate this condition. Of course, twisting the field itself is a challenge in itself, but it's even harder to shape it in a way that trapped and energetic particles remain well confined. And in our earlier SquidX paper, we numerically demonstrated excellent fast alpha confinement, as you can see in the plot. It also targeted low neoclassical transport, low bootstrap current, and lower electrostatic ITG-driven turbulent heat flux. Just want to add here that all these were numerical predictions under specific assumptions, not experimental measurements. I hope everybody is following. So, SquidX optimized an attractive idealized plasma boundary, okay? Plasma boundary is useful if external coils can reproduce the required magnetic field. We actually failed to find a practical coil set capable of generating it. I want to add here that it does not mathematically prove that no conceivable coil set could exist. We decided to run new optimization that introduces coil realizability considerations earlier, rather than treating coil design as a downstream engineering problem. SquidX also had an additional unresolved issue, unfavorable neoclassical impurity behavior, which the newer work sought to improve. And SquidC retains many attractive SquidX properties while allowing a 5 modular coil type solution with 0.27% average and 1.2% maximum relative normal field error. And the calculated positive core radial electric field, the electron route can favor outward neoclassical transport of highly charged impurities. As you can see in figure 5, the formation of an electron route radial electric field, which is the condition expected to improve impurity exhaust. Though I must add that it does not directly demonstrate impurity expulsion. As you would have understood by now, SquidC is definitely more engineering aware than SquidX. But it is still far from a complete fusion power plant design. Thank you. I hope everybody understood.
Thank you for that fantastic presentation, Anshuman.
We would like you to rate this presentation. And
just scan the QR code, so you will get a link. That link you can rate on these 2 parameters. And lastly, just write few lines of whatever you understood. I guess most of you got it 100%. So 5 minutes for just less than 5 minutes for that. Then we'll start with the next module.
Is the Wi-Fi working now? Are you able to? Okay.
At least on phone you can get the.
You can do this.
So the effectiveness of the explanation, how much you understood, and if you understood anything, then please write that. Yes. Yeah. So 1 is least and 5 is max. Sorry, we have not given a negative option, but deal with that. So 1 is the least you can rate.
Has everybody been able to open the page?
Can you? Yeah, it's dynamic now.
Wow.
That's heartbreaking, Anshuman.
No, 8.2% gave a 4. Okay, this is the.
Truly grateful for the 2%. Whoever rated 5 on the effectiveness, are you from this domain? By the way, we looked at every professor's or the applicant's domain and figured out something which nobody was from, and that's why we picked up this paper on nuclear fusion physics.
Oh, 6.1% understood everything. Wow.
Next. That's a correct understanding at least.
I'm waiting for those 6.1% commits to come.
Actually, SquidX is worse than SquidC. SquidC is better than SquidX. person who said good presentation, we actually named it bad presentation. So really surprised that you are one of the most polite person in this room. So anyway, we got the point. So let's just move on. So this same paper we will present once more. Between that, we will take you through four or five things, changes that we will make. So you can follow along, right? And then you can see what are the changes we did. And the hope is you end up applying some of those things to whatever your baseline approach today is. Maybe you don't do any of these mistakes. Maybe you do one of those mistakes. So everybody can figure that out. We'll take you through that. Next. So now that we are okay. At this point, it will be fantastic to form a group. We encourage everyone here who knows the least any other researcher. So find the most stranger person in the room and also see that you are from two different domains and pair up. So we want everybody in the room to pair up with one more researcher or professor who is the least known to them and who is from as extreme domain as they are. So don't make it mechanical. So just you have 2-3 minutes to do that. Please do that, and then move accordingly together. You can just readjust your positions. Please do that. No, so you have to have different disciplines, just to clarify, right? So a biologist should avoid a biology. Huh? Okay. Sorry, you said it. It's super important for the exercise. You will benefit a lot from today's. If you follow what we are saying, you will see the benefit of that in a while. So maybe stand up, find somebody who...
And there's also a case study which you'll need to do in a group of 6. So yeah, we'll need that.
Hold on. Yeah, pair. We have around 40, right? We have around 40. What karna? All those who have found a pair, please raise your hands. Pair is 2. Yeah. Each of you should know who you have paired with. It's okay if the 6 are sitting together, that's fine, but just pair up. Whoever has not found a pair, can you raise your hand? So, sir, you need to find somebody. Yeah. Sorry.
There are some who are in the same institution.
Yeah. So by stranger,
Find a stranger.
I meant when I said the word stranger or somebody least known to you, please don't make a pair with somebody you already know, which means people from your own university and campuses. So find a total stranger. And it will help if you spread out. So some of the pairs come to right side because we need an exercise where everybody needs to spread out. So yesterday, a lot of people spoke about being out of your comfort zone. So this is the beginning of that. We want to just get it done right away. Yeah, yeah. Is there anybody else now who is not paired up with somebody who is not from their college, university and not from their discipline? Everybody has paired up in that case.
And spread out a little, like two pairs little away from each other.
Okay.
Yeah.
Now a little bit of I will throw some comfort back at all those who are feeling a little uncomfortable. So we want 3 pairs to make a group. That means a group has 6. But don't change your pair, okay? We have everybody is paired up. 3 pairs approach. Each pair approach 2 more pair, make a group of 6, and please sit separately. So we would want there are 40 here. So maybe 4 groups on the left side, 4 groups on the right side, and rest in the center, please. We want 3 pairs to make a group. So as a pair approach 2 more pairs, make a group, sit together. Quickly. Yeah. The center column, you need to, some groups, please move to the right side. You will need space where others don't listen to what you're talking. You said there are 40. So I think there are 40, yeah. We'll see if some group is only like 2 pairs, then we'll see. We'll live with that. But try to, those who make group pairs of 3 will get some additional reward. So try to make a group of 6. Don't be the loser here. Yeah. Now, yeah, exactly. Yeah. But approach as pair. You need to find 2 more pairs. Yeah. All right, we have 3 pairs. I'm calling you group 1, okay? But okay, so I think take 6. If there is more, you return it. But so each of you please have this sheet. So this is group 1. If you have a pen, just write group 1 in your sheets. Did I give it enough? Of the 6, 1 will have. Sorry. Group A. Group A. Who is the group here? What is the group? But you have to, if you sit like this, then the group will not work. You will have to do a lot of activities here. So you can't sit in 3 rows. Please sit in maximum 2 rows. Yeah. 2 rows is better because 1 row will be too long. Yeah, this is okay. Okay? So you are group B. Yeah. Just, I'll tell you. Just have. Don't worry.
And this is one group here.
1, 2, 3, 4, 5, 6. Yeah. So all of you need to have this sheet, one each. Let's see how many I've given.
Is someone single here without?
So you are group
So
B.
his partner in his pair left. So he's looking for
Group B. So write
partner.
group name in your sheet. Group A, group whole is group B. Huh? You guys are not a part of any group. Okay. Who is the sixth here? 1, 2, 3. Okay. So you are group C. Each of you please have a sheet. Write your group name and your name. And this is, let's call it group D. 1, 2, 3, 4, 5.
You are here to join the workshop?
One each. If you have more, just return back. It's okay, I'll be a secretary. Remember your group names. So D, C, A, B. Okay. This is one group. Okay. So you are group E. Just keep one each, and if there's more, return to me. And group F. We'll figure that out. So group E, group F. Remember your group names because I will forget at some point. Okay.
You can join here.
Which is the group here? 3? 6. So you are
so you
group
can join
G.
here.
Okay. Each one has to have one sheet.
In this group.
This is one group. Group H. Write your group name because I will forget. So you need to remember your group name. H. You have 4 in.
This is one group, right? It's better if you sit in 2 rows. Because it will be
Group I. You're all together? Okay. Everybody needs to have one sheet. Just write your group name and your. Thank you. आप लोग नहीं कर रहे participate? Okay. So every group now has a name. A, B, C, D, E, F, G, H. Is there any group who doesn't have a name? Please raise your hand.
This is for a different thing. We'll explain.
Okay, so every group has a name.
Every group has a name. A, B, C, D, some letter of the alphabet.
Let's quickly check. Group A, raise your hands. Group B, Group C, Group D. There are more in your group. Okay, fine. Group E, Group F, Group G, H, I. Okay, so we have A to I. You all have a sheet. Amongst yourself, name yourself 1, 2, 3, 4, 5, 6, whatever order you want. In your sheet, make sure it's clearly written. Let's say group C can have C1, C2, C3, C4, C5, C6. And I think one of the groups has only 4 people, so that's fine. In your sheet, write your number. Every group should have one member called 1, then 2, then 3, then 4, then 5, then 6.
So your member ID would be, if your group is A and number is 1, you are A1.
Who is D3? Okay, great. So it's sorted, right?
H4. H4, who is H4? H, group H. Who is H4? So everybody allocate one number to each yourself, and you are H1 to 6.
Okay, this sheet that you have, it says evaluator's name, write your name there. It says group name and number, write your name and whatever number you have assigned yourself, write your institute name, and then we'll tell you what to do next. Okay, let's get going. Okay, everybody assigned themselves a number. Okay, one last quick check. We had I, na? I4, great.
Every one of you has a paper to explain to another person, right? A research.
Okay, let's begin the exercise. We call it the baseline assessment. In every group, team member 1, please, you will have to explain your work to team member 2. Don't have to use slides, don't waste your time, try to explain as much as you can. Team number 2, if you want, you can take notes. If you want, you can ignore. If you want, we leave it to you. Team member 3, explain to 4, and 5 to 6. Your time starts now, you have 5 minutes, go. One explains to 2, team member 3 explains to 4, 5 explains to 6. So in every group, 2, 4 and 6 are listening, 1, 3 and 5 are explaining. Clear? Go. एक बार विजिट कर ले, कोई डाउट हो तो किधर ले. मेरे घड़ी पे यहाँ था 9:45.
2 more minutes.
ट्राई तो कर थोड़ा, ट्राई तो कर लेने का ऐसे. अच्छे शॉट्स नहीं आ रहे मेरे. जूम इन जूम आउट है, ये रिकॉर्ड है. ये सारे. No, that's a remote control for this camera. It's a gimbal camera. It tracks me, so if I move, so it's just a.
It's tracking with that, is it?
This is a mic.
So what is it tracking? How does it know you are moving?
It has a AI built in, so it's just face
facial.
detection. Yeah.
Okay, okay.
So this camera has a gimbal.
Okay, okay. And then you're just moving it wherever you want.
You can do that also, yeah.
Okay, last minute, start wrapping up. All right, time's up. Time's up. Have you all finished your explanation?
Yeah. Time's up. So it's okay. Do not be perfect. So team members 2, 4 and 6 in each. So time is up. Team members 2, 4 and 6 in each group who just heard an explanation, take your sheet and do the same rating as you did Anshuman earlier, right? And the other team member, don't look, don't have to feel bad about it, but just let this be an exercise. You will also get a chance right away. So team members 2, 4 and 6, please rate the effectiveness, whatever you understood. And now don't ask again, but write in your words whatever you understood in your sheet that you have. Team members 2, 4 and 6. And team members 1, 3 and 5, just breathe, it's okay. Good times will come. We promise you that your pitch, wherever it is, let's say it's on a 7 on 10, it should increase to at least 7.5 on 10. That's the whole objective. So we wanted to do this baseline assessment. So don't just rate, also write one line at least of whatever you understood from the explanation. And don't correct it. 1, 3 and 5, don't look now, don't correct, your time is up. Give them their space. Okay, done? Next. Okay, now the turn of the other 3 who are left. So, but we will not do same to same. So, team member 2, please explain your research to team member 3, 4 to 5 and 6 to 1. So, you'll have to move around a little bit, but we didn't want it a quid pro quo where, I rate you well, you rate me well. So 2 to 3, 4 to 5, 6 to 1, move around if you need to. I'll give you 30 more seconds before I say your time starts now. Quickly move around, you have 30 seconds to find. अच्छा. Okay, your time starts now. Yes? Sorry?
What do we need to explain?
Your research paper. Yes?
Okay, not the one whom I heard before.
No.
Your own research.
Yeah. It's okay, whatever research you are working on, try to explain that. So one group has 4.
One group has five members.
5 members, which one?
That's
Which is A, B, C, D, F? I think group.
That group, you have 5 members, right?
Yeah, there's one group there with 5.
Which
4.
group has 5?
We
Okay.
have 4 now. He can join that group.
Which group? B?
The one.
What is your group name? Group C you can join. So we devise it in a way that it works only if it's even. So an odd group will have to suffer a little bit. वो तो ऐसे ही है, इसमें ज़्यादा टाइम लगा.
Two more minutes. More things on your mind.
Mind से निकल गया, डाउन हो गया मेरा. Because all the organization has been happening for a week or so, ये सब खत्म हो रहा है.
These are good exercises.
One more minute. Last minute. Start wrapping up. All right, time's up. Time's up, time's up, time's up. You can stop the explanation. And same thing, the person who was listening should use your feedback form and rate the person who explained it to you.
So 3, 5 and 1, please rate. One, 3 and 5, please rate 2, 4 and 6 and try in one line to summarize, 1 or 2 lines, whatever, to summarize whatever you understood. At this point, the researcher, please don't prompt, let them write whatever they want to write. It's okay. Sorry?
Sheet. So the feedback sheet that you got, it's to rate the other, your fellows.
No. Everybody needs to use only once, no? So now, team member 3, 5 and 1, you would not have used it the last time. So please use it this time to rate 2, 4 and 6. One person only gets it once. 2 cycles was 3 people each. Now, each of you can pass on to the actual researcher so that they can carry this as a memento from today's workshop, right? Pass on the sheet to the person whose effectiveness you have rated so that they can, all of you can now carry it. It's just a token to remember when you are forced to explain your research in 2 minutes, what happens. And you can laugh on whatever the explanation is written by the other researcher. It's for you. Okay, so all of you have exchanged the papers, pass it to the person. Each of you will have a good memory of this and will motivate you to become good at, better at your communication from wherever you are today. So all of you who have now with you a sheet of paper on which somebody else rated your effectiveness, please can you raise your hands? All of you who now have a sheet of paper on which somebody else rated your effectiveness, if you have that paper with you, please raise your hands. Okay. Those who don't have it, please get that sheet from the other person. Receive your rating and keep it with you and pass on whatever you have written to the person who you rated. Yeah. So this sheet is for all of you to carry with you. You can have a look at it, how much you were rated in terms of effectiveness, how much the other person understood your research, what have they written about your research. You can have a good laugh, and let's move on from this exercise now. So now everybody has a baseline on where they stand when they are forced to explain their research in 2 minutes. Hopefully we improve this baseline. To do that, we will use a playbook. So this takes us to the third phase before the tea break. We have a tea break at 10:30. In the next half an hour, we will explain to you a few things that all of you can use to make your research communication more effective. And to demo it, I will now, can I have everybody's attention here? Yeah. Okay. So two things that it's obvious, I'll repeat it right now. For every pitch that you make, you have to know who is the audience. In today, you all knew that there is a professor or a researcher, but from some other university, some other college, and different disciplines, so they don't have the context. So it becomes tricky, right? But in any case, sometimes a room will have a bureaucrat, sometimes a room will have a senior scientist, etc., etc. So you need to know the audience when you are doing your prep work. Right now, of course, I did not give any time for prep work, but when you have prep work, you need to know the audience. Think of what are the contexts and the frameworks or whatever they know and they don't know. It could be a school kid, it could be anybody, which is important to know. And number two, if it's a short presentation, then think of what to include, think of what feelings you want to leave that person with. Let's say it's a bureaucrat, they should feel this scientist should definitely be funded. That's a feeling. It doesn't matter what you include, what you exclude. If it's a kid, you want to inspire them. Remember, what should I include to inspire it? So these two things become good guiding principles when you are forced to do something in 5 minutes, 10 minutes, like it's somebody is forcing you, right? So what can you do? Of course, you will have to figure out some priorities. So if you can crack the feeling, doesn't matter whatever you said in 2 minutes. Nobody is going to remember anyway. Right? The burden is off. Nobody will remember anything anyway, but they will remember what they felt. If they felt, this professor does not know how to talk, that's what they will remember. If they think this professor is very good at explaining something technical, 2 days after, if you ask them what they understood, they will still not be able to write anything. I can assure that to you, however good you are. But they will say, but that guy, that guy really explains well. What did he explain, sir? That I've forgotten, but it was something around nuclear plant, something. But remember, that is in your favor. Don't underestimate it. If you know how you want the person to feel, and that is obviously linked to who the person is. Sometimes you want to make them feel overwhelmed. Let this person not understand anything. That was also should be in your kitty. You don't want somebody to understand anything, you can also play that card, absolutely you. But be in control, know the feelings. Now we'll talk about a playbook that we use to improve it. Or before that, I will give a demo. The feeling I want to inspire this time is, maybe I can be here itself, a feeling of sort of an inspiration and a breakthrough. I want everybody to feel that this research, somebody else's real research, by the way, but just hijacked it because we are not researchers, taken very complicated stuff. That's the feeling I'm going. Let's see if I'm able to achieve that. So I am here to present world's most advanced accelerator design. And to understand what a accelerator is, why it matters, you need to understand nuclear fusion and why it matters. If nuclear fusion becomes practical, it is going to be one of the biggest sources of energy and the cleanest. And that's why our research matters. When we make a great advanced accelerator, it takes us closer in that direction. Next slide. So again, making sure everybody knows what fusion is. You take two hydrogen isotopes, heat them up 100 million degrees Celsius or something like that, they become plasma, right? And when that happens, conditions are there for helium to be formed, and when that happens, a lot of energy gets released. That's a basic, but the problem is plasma is extremely hot. Next slide. So we need a way to contain something at 100 million degrees Celsius. It can't be a material. So we use electromagnetic field to contain this hot plasma, and accelerator is one of the approaches to achieve that. What you're seeing here is a real accelerator. I mean, you don't see the magnetic field, but it's the device under which magnetic field is there, in which plasma can actually exist and operate. It's right there in Germany, W7X. Now, this had a bunch of issues. Of the many issues we picked, let's talk about only two important ones. In this plasma, because we are heating it, heat should not lose from the center to outward, because if heat is getting lost, my nuclear plant will not work. I want to retain the heat in the plasma. The one that you saw earlier, there is a heat loss. That's why you start it and it stops. And likewise, when the hydrogen isotopes are colliding with each other, they create these alpha particles. They also carry energy. And I don't want this energy to be lost. But both of those things are happening right now in the reactor, accelerator that you saw earlier. So we worked to figure out how to solve for these, and we came up with Squid X. On the right side, simply put, if something is lower, it's better. So the green one is the W7X that you saw, and our theoretical paper came up with a new design, that's the blue. So lower blue means lesser heat loss in those accelerators. Likewise, here almost zero. Look at the fast ion loss. But we screwed up something very big. Next slide. What we did is we came up with theory of idealized plasma condition, where everything is perfect. That led to two big issues. One, we realized after a few years that we could not recreate that magnetic field in real life. No coil combination was able to give what we wanted in paper. That is number one. We also realized one important issue. Even if we somehow magically figured out how to create that sort of an ideal plasma magnetic field to hold that, it will become so ideal that it will retain also the impurities in the plasma, which should actually be expelled out, which happens in the German accelerator. So we had to go back to the drawing board and fix these two issues. How did we fix this? So, not going into technical details, but it's an optimization problem, right? We are figuring out some numerical optimization to get the right electromagnetic field that serves the job. Earlier, we made it extremely optimal. In this paper, we have put two constraints. First one is called the Kaplan's magnetic gradient. Essentially, think of it like this. Earlier, we had an architect who was told, design the perfect building. This time, we have also put an engineer right in the optimization mix, so that no such coil combination gets out, which is not possible in practical life. Likewise, earlier we made it ideal. This time we put electron route optimization. Think of it like a travelator in the airport that we have seen, right? We walk on that to increase our speed. If you make it slightly gradient up and put something very heavy on that travelator, it will probably keep going up. But if I put something very light on that travelator, it will probably fall back, which is the technique that we used to make sure impurities travel up, because impurities are heavier, while the useful alpha particles and everything else remains inside the plasma. That's an analogy I'm using, but in reality, it's an optimization technique. And when we did that, we have now solved for those two big issues in our own design, and hopefully when this is implemented, we would now finally have, in few years, the world's most advanced accelerator, which will hopefully make us closer to a real practical nuclear fusion plant. Thank you. So let's just take a same QR code based poll and rating on the effectiveness and how much you understood. And in one line, if you again want to write.
Everybody is able to open the polling page. Has everyone taken the QR code? I'll then change it. Anyone else yet to scan the code?
Slide one. Start. Next. All right. So as everybody can see, and as expected, numbers have improved. There is little more clarity on what you understood. We obviously picked up a very hard, technically most challenging paper, which even for us, we have to keep reading it because we are not the researchers. It is a tough paper and only so much can be grasped, but it was a relative measurement that you wanted to see. So what are the changes that we did is what the playbook is about. There are 5-6 things that we changed. We'll take you through that, and hopefully after tea break, you get to deploy that in a case study that will give it to you. Don't worry, delete the no? Okay. So these are the. So anyway we said always know the audience. That goes without saying, and good to know the feeling that you want to sort of evoke. So 5 things that we want to talk about is 1, don't bury the lead. 2, tell why it matters. Prioritize for the middle. Use analogies, especially to talk about technical stuff, and there is something called ABT structure, use that. So number 1, don't bury the lead. So one of the things that you noticed what I did was, I straight away said that Squid C is the world's most advanced accelerator design. Net, that was the whole point of the paper. Sure, one needs to know what our accelerator is, but then that takes 30 seconds to explain. There's a lot of things that people need to know. But what I did, instead of going in a chronological order of first explaining this and that, I right away first said, this is what I am here to tell you, that we have come and made something most advanced. Because after that, I really didn't care if you understood or not, because that is what you will remember. These guys have done something most advanced, something called accelerator. If you remember, you can write it down. If not, you will forget it, which was by design. So this thing in newspaper also, right? We read articles like, bus fell down, 200 people dead. Sometimes we read the article, sometimes we don't need the whole report, which is called don't bury the lead. If you are short on time, think of the line that in itself is complete. And if it's your research, it's difficult. I totally acknowledge that. Maybe take somebody else's help. But if you can do that, you have already done your job. You can just repeat that line few times. Okay? So that's called don't bury the lead.
Second one is tell why it matters. So what happens, what changes if this research comes into play? So that's what, when we say tell why it matters. Why should the audience care about your research? And couple of points to note here while doing this. Don't go on and on about it. Just say it in short, one line. And second, if you have an audience which already knows the context, say somebody from your own department or your fellow researchers, they have a context of your research, you can skip this part. This is only where the audience is mostly uninitiated.
So one thing that I forgot is when you're already saying in the first line what the research is, the question might be what do I say in the end? Because the typical approach is I did this, then I did. So you can figure out multiple things for the end. Good idea is just to repeat it in my opinion because people forget what you said it. So in the end you can say the same thing. So that clarifies it. Then what do you put in the middle? So if you have 2 more minutes, then it becomes tricky. So the logic is simple. If you know the audience, you make a list of all the things you can talk about. In the first presentation, which almost nobody followed, we wrote down squid eggs solved for neoclassical transport loss. It solved for heat loss to turbulence. It solved for bootstrap current, etc., etc. Now, if this paper is a real paper, if you actually go and try to do some research, what were the most critical aspect of the actual problem? Then you will notice that other things, that W7X in Germany is not bad. It already is decent in reducing bootstrap current. Plus each of these now require explanation. What is it, why it matters? So 6 points means that you can't cover it. So in the next time I picked up specifically only heat loss to turbulence, and there was something called fast ion loss. That's the first point. Because that's true. We did our own research and found out these are the ones which are the most important issues with the existing accelerator. And if I'm going to be given 2 minutes, then I have to let go of all the great work that I did. So sure, in a 2-3 year work, some PhD person would have worked only on bootstrap current. So it might feel bad to leave it out, but that's a priority choice you have to make, because if you include everything, anyway nobody is going to get anything. So rather make it about the audience and not make it about your research lab, your research group, what you put a lot of work in. Nobody cares about it. It's possible that you spent 6 months on doing something which eventually was not part of the main story. It's okay, right? So stories are about my audience. It's not about what you think is important. So in this particular case, in the next slide you noticed, because I only picked up 2 things, some of you did follow it, because everything became easier then. Oh, we had 2 problems, we did 2 things, then we solved it like this. You would have forgotten the details, but at least you could follow along. That's the point I'm trying to make here.
So these are the 2 that Amrit chose to speak about in his presentation. Then there is trick about using analogies, especially when you are talking about things which is hard to visualize or hard to imagine. It's too deep tech, it's at an particle level. While you are deep into it, you understand it well, the audiences who is listening to it for the first time may not be able to appreciate that or imagine it. That's where analogies really help. They come into play and they can help the person visualize it, understand what exactly you are trying to say. So for example, the analogy Amrit chose to speak about in his presentation was that earlier design was an ideal design, but it was not real. When you would go on to make it in the real world, it will not be possible. So the analogy used was that it's like an architect who was earlier making a design which was ideal, but not actually possible to make. So this time we made an engineer sit with the architect who was keeping a check on the design is actually doable. It's possible to make. So that's how the audience who doesn't know your subject, doesn't know the particle or the domain you are talking about, these analogies help them imagine it.
Okay, so dumbing down is one way where you absolutely skip and say, no, it's too technical, let me not talk about it. As we said, we have seen some professors just say that, oh, this is too technical for this room to understand. Believe me, you have just not found the right analogy. Everybody knows something, so you can always explain the broad concept of some metric that you have used, but don't talk about the jargon, right? Talk about something which they will understand, because that is better than skipping it altogether. Or saying, or using this phrase is what at least I personally don't like, which says, oh, this is too advanced for you to understand. That is actually the explainer's problem, by the way. The audience will understand if you figure out some way to explain. The analogy is many a times for technical terms is super useful. Last is using something in the overall narrative we call ABT framework, and, but, therefore. So in the first presentation of all the other problems, one other issue was, it was like we did this, we did this, we did this. So there is no storytelling there. In the second one, if you noticed, there was a narrative which said, in the beginning I was explaining what we did, but it soon said, there is this thing in Germany, but it has problems. Notice the but there, it's by design. You can say it's in Germany, there are limitations, we fixed it, now we are publishing the result, it's easy, difficult to listen to that. If you say it like this, you look that thing in Germany, but it has few issues. So, when I say therefore, it could mean so. I mean, these are not specific words. Instead of but, you can use however. Instead of therefore, you can use so. But the flow is, always figure out a word which is, we call it a contrasting word. So when you say it like this, our ears pay more attention. That's a simple engagement logic too. So there was this thing in Germany, but it had a problem. So we made a design, but we made a mistake. So we fixed that mistake. So even if, any simple thing, right? I was hungry, so I went out, but the shop was closed. So I wondered what I need to do. So I was thinking. See, all of you are now looking at a random story which doesn't mean much because of the and, but, therefore framework. So in a longer narrative, in a shorter narrative, maybe you'll get to use it once. Between slide 2 and slide 3, maybe you can do it once. If it's a 30-minute presentation, you will be able to do it multiple times. You just need to look at your own presentation and see, you know, I can throw in a but there, and people will pay more attention. So that's a straightforward, simple playbook. That's it, na? So don't bury the lead, tell why it matters, prioritize for the middle, make a long list of points and prioritize the most important points, and try to make of and, but, therefore. After the tea break, we will give you a QR code to scan, which will be a 20-page, another researcher's case study from a totally different domain, again from whatever you are. And we would want you to make a 2-minute explainer as a group. Every group will now, after tea break, work together to first 5-10 minutes just read the paper, use Saral AI, do whatever to understand what the paper is. Then you make your, and you can use AI in all of this, by the way, right? This is a framework. You can ask a AI tool like Saral or ChatGPT that, hey, give me an analogy. It will do that. Your job is to just pick. Like, it will give you something, you might say, oh, this analogy is not right. So you can do that. So once you have this framework, you don't have to do it manually. You can use all the tools that are there for you to get the right thing. So that is where we are. We read early, which is great, so we can have more time at tea break. I don't know if the tea is out there, Shrikant, but.
They'll be setting up, but we can take a break.
We can take a break, but we are also here. You can ask any other questions that you have, but after the break, you all get to use these 6 things in a new case study as a group activity for 20 minutes. Any questions that we have? Yes, sir.
I have a query. So, like, you have created a wonderful video with animations, like whatever shared by Dr. Srikanth sir on today morning. May I know which AI tool have you deployed to create an animated videos?
So we use a platform called Leonardo. That platform offers many different models for image generation and video generation. It's called LEO-NARDO. It's just a multimodal platform, and it provides you all the different models from Gemini to ChatGPT to CDance, etc., etc. We pick and choose based on, some models are very costly and some are cheaper. So we figure out for which use case. Some of the common ones for image generation that we have been using lately, it changes every 3 months, is ChatGPT 2.5. So for that animation, we first make an image. And then once we have the image, then we feed that to any other model to create a video. For video, there are 2-3 models that we use. One is Helio, I don't know if you've heard of it, but you will figure it out. So Leonardo is a platform, it's a drop down, it will tell you, it will ask you which model you want me to use. It has video models and photo models both. And we keep on figuring out which is giving the best result at the cheapest price, because there are some costlier models, but we avoid using that because it sucks up all the tokens. So maybe what we can do is, you can scan the paper right away so that it will give you more time to read the paper, right? And after tea break, you can actually work as a group. So Anshuman, yeah. There is a QR code for the original paper. We have also made a simpler 2-pager note, 3-pager note, which is a handout. So you can scan both. This is your exercise for the case study. Case study में करना है, explain कर देना.
You should be able to download it now. Can someone check and confirm?
Yeah, I just had a very quick question. So this framework is quite interesting. And when you moved from the first initial presentation, which was a bit boring, to the second one, which is more interesting, I could see that the slides have transitioned. It's not the simple presentation of the data, but it's more of visuals. My question is are there any AI-based tools or any tools which can kind of convert some generic some presentation like a paper? Like yesterday we worked on this Saral AI, so which can convert that into a presentation. So are there anything wherein we can give a prompt like put it in this type of ABT structure and convert this paper into a presentation or something? Or how do you do it?
Mike.
So once you all have the framework and you know what you want, so you need to first know that you want a and but therefore framework. And also therefore you should be able to review that did the AI give you that or not. Right now I haven't tried what are there in Saral AI, but you can give that, check that out. But for now, the next paid model of ChatGPT, we use, by the way, a lot of things, but not to complicate it, right now for a 2000 rupee per month subscription, ChatGPT does all of this for you. You upload a slide and ask it to make it better. The only question is this better, if you don't define it, then don't come back to me. If you can define what you mean by better it could mean add more, take out less, etc., etc. But you will, from a technical perspective, ChatGPT can do for you. You need to ask it to do the right stuff. Can other models also do 100%? But it's just that I have over the time realized few advantages with ChatGPT compared to other models. As I said, that itself changes every 3 months. So today, if you ask me, for the last 1 month, I have started using ChatGPT for all the image generation. For the 2000 model, it generates image itself. But yeah, this is just, I'm not a advocate or a sales commission of OpenAI here, but most of the stuff that we did here, we used a lot of ChatGPT to generate these images and things like that.
Great.
I think it's the cost versus optimization.
Gemini, Notebook, all are equally good, and I think even Saral, PK can maybe tell more about it, but whether it can enhance it with visuals and all. So Saral is another tool.
Thank you.
Yeah.
just to let you know how powerful ChatGPT has been, the website, the webinar showcase, the posters, all the LinkedIn posts, everything was done using ChatGPT for this particular conference. It's a very meta thing in the sense that we have used it extensively. It's extremely powerful. You have to sit with it. So you really have to sit with it. You have to prompt it, because again, the other, I think Trayambak was asking yesterday, is the visuals were not really proper, or I think even you were asking, but the visuals that it generates may not really map to what the actuality is. So if an expert sits behind it and says, no, this is not proper, correct it this way, correct it that way, it gives you a very high quality output. And I've seen that. I've also used it in my presentations. I recently shared this teaching video. That teaching video was like a 2-week binge or deep dive into ChatGPT. I got all the information out. It gives you an order of magnitude errors. It gave me a 3 order of magnitude error on some energy values. I said, what are you doing? So that also happens, but then that's where the discipline expertise comes in. So it accelerates your workflow for sure. The 300 rupee version, I'm using that. Any idea about ChatGPT Scholar? No idea. No idea. Now the 300 rupee version has got ads. That's what I got an email. It is not.
Yeah, it's a very naive question maybe. This is quite new to me, but it's a learning curve. I'm learning from it, from your exercise. It's amazing. In all these whole things, there's the last 1 hour that you said, where is the individualistic approach to make a presentation which should be good in terms of effectiveness of communicating to the people in the audience? It's everything is being done by some agency. In case ChatGPT, there's that. The individualistic approach, where from it is coming? It is mostly the machine-generated approach that one is giving to the other. When I'm evaluating somebody's, say, they explain to each other 5 minutes saying, that evaluation aspect should be original. It should not be machine-generated. Then everything is machine-generated. You don't need people sitting over here, right? So my question is, how far that we should depend upon the machine-generated approach or effects or whatever, prompts, and when does the individualistic approach of a, say, a brilliant mind doing something, same thing is being done by somebody who is not really interested, how does it come into the factor into the whole approach of what you had exercised?
I would like to answer that. So, sir, anything that we, in the playbook, everything that we talked about, the tips and tricks, none of that involves any tool as such. They are just ideas. You can choose to do that on your own, like take a pen and a paper and write, or you can choose to do it through ChatGPT or Gemini, whatever tool you want to use. So they are just ideas. We use these because we have not done that research. We take it as a paper as an audience, and because there's years of work that goes into that publishing that paper. It's not possible for us to comprehend all of that, and it also depends on how much time we have to create that explainer. But if you are the researcher who has done the work for years and you understand all the nitty-gritties, then you don't need any tool or any machine-generated input to create a 2-minute explainer. Just the ideas you implement while you are writing about it.
I'll just add one thing to it. As a researcher, the individualistic thing is your research, in my opinion. So I don't think the burden is on each person to become a great communicator. I mean, you could choose to be, but the world's real value is coming from your research. The communication is feeding to that research, because for that research to happen, people need to know what you are doing. So it's all interconnected, but look at the core of it, which is how a lot of this world works, right? A manufacturing company might realize that my core is manufacturing, but if nobody markets it, I can't sell. So this is how we look at it. So individuality can come from multiple places. Even in our framework, it says don't bury the lead, and it says tell why it matters. At what point do you tell why it matters? Now, If you have zero clue, at least ask ChatGPT something better than nothing, right? If you can't even do that. But if you have a good conviction of I want to not tell why it matters, but make my audience guess, you are that person. So I guess these tools are hardly rigid. Those who don't know much rely too much on the tool, which is I think fine.
Yeah.
And those who know a lot will rely less.
Right. But it should not turn out into that I do some research which is important to me and I know all the nitty-gritties about it, but the science communication is being done by ChatGPT.
I don't think that's possible. So that will be the worst communication.
Right.
So,
Yeah.
I mean, in all honesty, any automation tool which takes your communication, churns something out, I would say if nothing is being told out, it's better than that. But it will obviously not be customized to what you want to say, the agenda that you have, the theories that you want to build, because all of that is, in the chat GPTs or AI's parlance, your prompt is your customization. Your paper is your input. That's why it's called chat GPT. You're chatting to it. So if you don't know how to chat, then we don't know, but you write 3 lines, that is you, and the AI will respond based on how you chatted with it.
So just very quickly to add that also when you're using such tools, hallucinations are still there, it's still prevalent. So you do need to kind of make sure that there are no hallucinations, and there also you can bring in your own customizations. The point made about customizations for sure was correct. So,
Yeah.
Great. So we do have tea served outside. You can carry on the discussions.
Just before we break the tea, can I just quickly tell what we need to do for the case study?
And
Oh
after
yeah,
that
please. Sorry about that.
So you would have downloaded the paper and the handout. Everybody was able to do that?
All those who have got the paper and in their phone or laptop, please raise your hands. Okay, so everybody has access to the paper and explainer. Okay.
So if you can read the paper, read that. It's a 35-page paper. If you would choose to not do that, you can read the summary handout. It's a 4-page summary. You can use any of the LLM tools, feed the paper, and ask it to explain it to you. It's up to you how you do it. What you need to do after you have done that is apply the ideas that we just spoke about in the playbook. Apply those ideas and create a 2-minute explainer for that paper.
We don't mean a video. Nobody needs to make a video and all of that.
Yeah.
You should be able to write in a page or something where it takes 2 minutes to deliver it. And if you want, you can make a PPT also, but I think just writing it is good enough. That's a group exercise. We'll retell it after we come back from the tea break. Let's go out. Thank you. अभी बोलने का फायदा नहीं है, भूल जाएंगे सब. That's all you have to say. पढ़ लो. ये next करते हैं. Welcome back everybody after the tea break, and now you all will get to do those 5 things that we did in our stellarator presentation. This is the paper. It's on a astronomy paper, right? We picked up a domain which is outside everybody else's domain to make it equally hard for everybody to do this. This is a group exercise. As a group, try to write down either using maybe 2 or 3 slides, or it's okay if you just want to write in a, a 1-page document. A 2-minute explainer of the paper whose QR code is there on the screen. As a group, make sure that you do all those 5 things. Don't bury the lead, prioritize for the middle, use some analogy to explain something technical. Yeah, and the and, but, therefore structure. So in your script there should be few buts, few therefores, etc. We are here to help. Whoever wants to ask questions to us as a group, if you are writing a script and not sure, we are here to sort of answer that. So the time is, we'll stop it at 11:30. So do the best job as a group to write the cleanest, most effective 2-minute explainer using these 5 things.
Someone here still needs the QR code, otherwise I can move to the checklist slide so that you can refer to it. Raise your hands if you have not yet downloaded and need the QR code. All the groups are back as they were. Any group missing a member?
Yeah. So, but as a group, you discuss and see if in the first go it might not do proper. So, you just question whatever result you are getting and see if this is a true white matter.
Do we need to do that exactly in this framework, or do we
Anything is fine. I mean, yeah. I'm saying, but as a group discuss, what happens is, if you, whatever tool you use, it will give you something. You figure out how do you know if it's giving you the right answer or not. Mic is on, no? Okay, let me switch off the mic.
महेश जी, आप क्या ऊपर में हैं? हाँ, ऊपर ही हैं। राकेश जी ने आपको कुछ बोला ना वाईफाई के बारे में, वो थोड़ा ठीक करना है ना, तो बताइए क्या करना है। सब तो वाईफाई के लिए वेट कर रहे हैं यहाँ पे। मैं सुबह 1 घंटे से 1-1.5 घंटे से उसी के पीछे पड़ा हूँ। थोड़ा आके नीचे आके थोड़ा हेल्प कर दीजिए प्लीज़।
in every group, maybe use one person's laptop for the final output that you're working on. That will be easy instead of everybody doing on their own. It's a group exercise. want to reiterate the objective of this case study exercise. It is that as a group, all of you have understood these points, because it's possible that somebody thought don't bury the lead means X and somebody thought Y. So when you do it as a group, that's the only objective of this exercise. Do it as a group so that it's clear that these things are what we meant. So if you don't do it as a group of 5-6 people, you will live in your own cocoon and think that you have gotten it, but you haven't really understood it. And for those using AI tools, for example, to let's say feeding this framework and generating it, assume that the AI tool is giving you some wrong answer. So as a group, figure out how can you ask a counter question to let's say ChatGPT to make sure that it has done what you've asked it to done. Don't assume it's right. I can tell you that it is giving you a wrong answer, or maybe the suboptimal analogy, right? If you're generating analogy, it might not be the best. So figure out a way to push it. So take this half an hour to improve whatever you are making. Read it, make sure it gets over in 2 minutes. It's an iterative process. Whatever you have generated in 5 minutes, improve it as a group and see if you're able to do all of these things. Internally, one person who can stand up and mention the first 2 lines which indicate to everybody that you have taken care of point 1. Don't bury the lead. Right away, tell what the paper is about. Take 1 minute, then we'll start. All right, let's get started. Group A. We'll pass on a mic.
So we have to go with the first point. Just
yeah,
the first
you
point.
mentioned
Okay.
the first 2 lines of your
Okay.
explanation.
Okay.
Hopefully this happens, but let's see.
Okay. So for the first time, scientists have used James Webb Space Telescope, and they have identified the minerals on a rocky planet beyond our solar system, revealing.
So it's we have presented like this, that is autopsy of a dead world, and we have discovered that the rocky exoplanet LHS 3844b is a completely naked and airless rock.
Okay, thank you.
Group C.
Yeah. Group C.
Group C.
Okay, sorry.
C.
But we can do it, it's okay. The order in material, yeah. What is the group number?
So it's group C, right?
Yeah.
Group C.
You're group C?
Yeah, we're group C.
But group C is there?
C is there.
Hey. It's.
Let them present, no?
I thought you were all together, no? Okay. Group C.
Yeah. This is Group C.
Yeah.
there was a research finding by using James Webb Space Telescope, measured the atmosphere on the LHS 384 planet.
Okay, thank you. Group D. This is not a competition, just to make sure that everybody has tried to do their bit to make sure that the point of the research comes first. It will vary from group to group, that's totally fine. We have group D.
Yeah. So the title could be A Planet That Lost Its Atmosphere. So it's basically, can a rocky planet keeps its atmosphere when it is constantly bombarded by intense radiation from its stars?
Okay, thank you. Group E. Mike is coming to you, sir.
So this is from Group E. Basically, study shows that scientists are interested to search a planet which is similar to the Earth. So they search one planet which is LHS 344b, which is far away from the Earth, and found one this planet as having no air, having the ancient rock-like structure on the surface. Basically, it is found that they have not, without landing on that planet, the heat radiation or heat flow from the planet, they have evaluated, or you can explain what is the structure and what is the atmosphere of the Earth. They try to explain in this paper. Thank you, sir.
Thank you.
Thank you. To reiterate, this is not a competition and Group A is not winning for sure.
Group I.
Yes.
So the question is.
Sorry, it was E. We have F. Sorry. Yeah.
So good morning, sir. This article represents about the direct infrared telemetry of LHS 3844b, which mentions about the surface composition and atmospheric deletion on an ultraviolet period M dwarf exoplanet. That is, it is unraveling the mystery on LHS 3844b, that is luminous high precision stellar planet. How do we identify rocks that we cannot see? Comes under don't bury the lead. And the brutal red dwarf A violent hot star mystery. So we are unraveling this part more in here.
Okay, thank you. This was F. We have G now. Right? It was F, right? Group F. G.
So this study of the origin of life to find an exoplanet, it's important. So to understand the origin of life, we need to understand the exoplanet's weather. So the different gases. So in this work, what they did actually, they tried to understand the weather of this exoplanet LH3844 by the JWST mid-infrared regions.
Okay.
So what they found, actually there is no volcanic gases found.
Okay, thank you. Group H.
Hello. Actually, scientists just worked out what kind of rock covers a planet 49 light years ago, and they found that it is a basalt rock, and they have compared with that earth rock like a granite, and they have studied their properties, the basalt properties, and hot and dark side, and they identified that the basalt is giving only the dark type of output. So based on that, they understood that there is no atmosphere existing in that planet.
All right, thank you.
Thank you.
Group I,
Group
the last
I.
group.
Okay, Group I. Our lead starts with a question. Can we determine what a rocky exoplanet is made of without physically sampling it?
Thank you.
Thank you.
So there was a question earlier about how if we have some tool and everything, individualization happens. As you all could see, even when the framework is same, each group had their own take on what it means to don't bury the lead, right? This would apply to every single thing. Each group, each person eventually will figure out what does it mean to prioritize in the middle. Each group will have a different end to it. And we are not here to evaluate, but hopefully by virtue of this exercise, all of you realize that even when the tool is there, it's not straightforward. You can't ask a chat GPT, it gives you an answer and you can use it, because there are 10 different ways to sort of summarize the same research. So it becomes very individual at one point of time, which hopefully answers this question. But these tools are useful. It's good to do this and not to do this. The how will vary based on your personality, what you believe in, etc., etc. So now with the conclusion of this, sorry.
The Wi-Fi is working, I'll just tell them how to log in.
Okay.
So the Wi-Fi is working, finally. You don't have to use your data anymore. To log into the Wi-Fi, first you have to go to IIT Mandi Wi-Fi, that one. So where it was asking for password, you have to enter Wi-Fi @IIT. So all small, Wi-Fi @IIT, no spaces. And after that, so that would log into the network. Then you have to also sign in through the gateway. So a page should automatically open up. So it will say sign into Wi-Fi. You can click on that. Or if a page does not open after that, then you just have to go to the IIT Mandi web page, which is iitmandi.ac.in. You'll be taken to the gateway. There you enter the 2 passwords which I have shared with you in the WhatsApp. So I'll repeat once again. IIT Mandi Wi-Fi, connect. Password is Wi-Fi @IIT. Then you'll be able to sign into the network. If you are not getting any web page like that, you go to iitmandi.ac.in, the home page of the institute. It will automatically take you to the gateway, right? Username, and I shared the in the WhatsApp. There are 2, username and password. You can use either. Done? Okay, fine. One person has done. If you are not able to log in, ask him.
वो QR कोड डाल दे. They will all know ना. वही है और कुछ नहीं. नहीं पता उनको अपने पेपर पर काम. Okay, so this brings us to the last leg of our workshop, where all that you have learnt, now it's no more a group activity. Each of you, please prepare our 2-minute, again I would say talk. After lunch, you can just simply talk about your paper, or if you think that 1 or 2 slides are important to be shown behind you, that's also fine. We can display that. Anshuman, QR code. So from now till lunch, we request each of you to make 2 minutes, the same thing on which you made a video basically, but you can compress it down to 2 minutes using the things that we have spoken about today, right? Make sure that you, first line itself, tell right away what the paper is, make sure at some point you highlight white, all those things, don't repeat it again. And we are here. This is the QR code. Whoever wants some slides to be shown, a form will open, you upload it there. Because we will not be asking everybody to give their pen drive and all of that. We will play it in the order of group numbers and team numbers, right? We'll start with A1, A2, A3, A4, A5, go all the way to I6, okay? And that is the order, then. But it's okay if somebody doesn't want to make a presentation, it's totally fine. 2 minutes fixed, because there are a lot of us. The moment 2 minutes gets over, we will move you out of the stage so that everybody gets a chance, right? So all the best. Till lunch, you have the time to sort of work on your 2-minute presentation or talk, and we are here. You want to ask us anything, we can help you look at it, tell if the storytelling is getting fine or not. And we all will get to listen to each other's research after the lunch. That's the plan. So
to be clear, it's for your own research.
Yeah.
The planet, exoplanet, stellarator, all are out now. You have to create a 2-minute explainer on your own research and then present it in the second half after the lunch.
It's the same research for which you made the videos. And I mean, those who are here who have not participated, look at whatever research paper you are working on, you have, take that as your research. So for those who have participated, you already have made a video. For others, you should have one paper on which you want to talk for 2 minutes. Anshuman and I can review if somebody already has something to show, if you want some feedback, if this is good, bad, etc. Feel free to just make use of us. We can give you a third person's perspective on your presentation.
I remember someone mentioned that they already created a 2-minute explainer. So it might be a good idea to just validate it with the checklist if you have applied all the 5 elements in your explainer. If not, you can revisit, change it, revise it.
You could also present it again to the same person you presented earlier, right? Now that you have some time, look at your earlier pitch, see what you want to change, present it to that colleague who you presented earlier, see if your quality is improving. Make use of this time, make use of us. All the best.
So just for your information, I have, for the benefit of the IIT Mandi faculty, I have also circulated the list of participants. Shyam has also done that, who are here today, and I have invited them to the 2-minute presentations. So if this is something that you would like to consider, say you can take your audience to be a potential collaborator, for instance, so you can consider that also, or whichever way you want to go. I am just letting you know that I have extended an invitation to the faculty. Thank you.
I have put the checklist on display for now, just for you to refer. We'll leave it here for half an hour. Once you are ready to upload, we'll move to the QR code. Thank you.
So, yeah, sorry.
Just a quick word. Sorry, can you two students stand up again? What are your names? Can you please say that loudly? Ashish and Ravindra. So Ashish and Ravindra have a camera and they are going to shoot you a video. So they're going to, we would like to make some small videos of your impressions of the workshop. So they'll be around. In fact, if any of you are relatively free now, maybe you can go with them and they will take a short video of yours, maybe 2 minutes, 3 minutes, and we'll put it together and we'll put it on LinkedIn and other social media platforms. The other thing is I strongly request you to also use your vernacular language, because that is the essence of today's workshop, or the conclave in itself. Science belongs to all languages. So if you would like to give the interview in your vernacular language, be it Bengali, Tamil, Malayalam, Telugu, please do that. We would appreciate it. Okay. So now they are framing some questions. So whenever you are ready, please go find them, or they will come and find you. So, and then do oblige them. Thank you very much. Please carry on. Thank you.
So I want to make few points on some things I am noting on people's slides. Don't put too much of content on your slide. So this is a slide that is useful when you present. If you have 6 bullet points on one slide, you have learned nothing from our case study that we did. A lot of you are using, I think, let go of this mindset to squeeze in everything in 2 minutes. That is not what we taught today. Start a beginning. Beginning is not the name of your paper. So I want to clarify. Some of you have just written a very technical name. That is not the beginning. Beginning is the finding. What was the eventual outcome of your research is the beginning. It might sound very confusing, like this is in the end, but believe me, say it right away. After that, nobody in the room wants to listen to you, I can tell you. It might feel bad. When you come here, nobody wants to know about your research. This is your audience. But if you can say it very nicely in the beginning, world's most advanced, I'm not saying make it up, but you look at your own research and see how in 2 lines you can say it in the best way possible. If you can't do it, none of your PPT or your slides, all the work matter to anybody, I can assure that to you. So this little point in making sure that every technical detail gets in, and almost all of you are just trying to do that right now. Focus on your opening line. After you have done that, you ask yourself, what is the end in that case? For some of you, it could be, there are 2 limitations, so we will do one more round of research. For some of you, it could be, these are the recommendations. I leave that to you. You will realize just this will take 2 minutes. It will take you 2 minutes just to open and end. So between, I leave it to you, don't struggle too much on squeezing in all your slides. You don't have time for that. And if we do that 5 minutes, then none of us will be able to finish it. So prioritization is what I encourage. Look at 2 points which matter. Delete everything else from your slides. Everybody's slide I am looking at, there are 6 bullet points, 3 diagrams, all put together, trying to explain to this audience who doesn't even care about your research. So I don't see the point of you trying so hard. These are not your peers. They are all preparing their own research. So make it interesting. Give them something which is worth remembering, like a layman. And if you pick one technical thing, use an analogy. Many of you are not using an analogy. You just, I don't know why not, but some of you have, some of you have not. So one good analogy is what everybody in the room is going to remember about your pitch. One good story. Think of it like whatever, right? So I hope, I look forward to that. Everything else, you might even say something incorrect. Nobody will know here in this room unless it's recorded and peer reviewed. So don't have that pressure. So request you to keep very clean slides. And if you don't want slides, totally fine. You don't need slides, to be honest, right? To open for this audience. Especially those using AI and all of that. It will create very dense deck for you if you ask it. If you ask it specifically that please only one visual, 40 words in a slide. You will have to ask that to that tool that you're using if you're not doing it manually. Otherwise, I am seeing this huge infographic which nothing can be read in that slide. Please don't commit that mistake.
40 words in a slide is a lot.
Whatever. No, but I saw some slides which look like a whole infographic poster. I mean, dude, this is a bad way to use ChatGPT.
So Anshuman, Amrit, hi. How are things going? Do we need some more time, or how would you like to do it? Just to let you know, the lunch is ready, that's what I was asking.
I think at this point, see if you can wrap up those who have, because it's a never-ending iterative thing, so, and it's your research, so even after this workshop you can do it. For the purpose of today, we have the lunch starting now, and then we will assemble what time, Shrikant?
We can do a slightly relaxed one.
Okay.
It was 2 o'clock.
Hmm.
Given that the number of participants are less, we should come here at 2 o'clock. We
Okay.
should start by 2:10.
Okay. So those who are done can keep uploading to this QR code, and we will meet here at 2 and start from A1, A2, A3, P1, B2, B3, that order, right? But everybody shows up so that you all listen to the effort done by others. And those who are still need more time, you can do it. But you know, we have to come back at 2 and the lunch is starting. So I leave it to you. Some of you want to fast, totally fine. This place will be on, I guess. So yeah. But we reconvene and do it at 2. If your deck is not uploaded, then unfortunately you will have to just speak here. We are not playing any video, at max presentation or something, but you have to speak, and after 2 minutes we will ask you to keep moving out. So a lot of you will realize that you will never reach the end of your presentation. That's how it's going to be, so be okay with that, because if you don't do it, then it becomes a never-ending barrage for everybody else. Yeah. All right. Yeah.
Yeah, great. Okay, so yeah, lunch is served. We are also doing a photograph session before lunch, yes. After lunch, they are already here. I've already told them. So we'll do that and we'll go. What I would say, yeah, before we leave, I would like everyone to thank today's workshop coordinators, Anshuman and Amrit. A wonderful job. We have frameworks. There has been a lot of interactions going on. I was very happy to see it. And we'll see the fruits of our labor in the second half. I ask you all to please come back at 2 o'clock so that we can start no later than 2:10. So we'll start as early as possible, but no later than 2:10. And now we'll take a photograph outside. Yeah, yeah. Yeah, depends, it's slightly drizzling. So if we can slowly make our way, that will be great. Thank you. Somjit sir, okay, fine. Yeah. Exemption, internal candidate. B2, B3, B4, B4, B5, B4, B5, B5, who's thank you. B7, B7 nahi hai. C1, C1, C2, C2. Do you know who is C2? Shubho or Pranamesh? Pranamesh was not here. C2? Okay. C2 is not here. C3? C4? C4? और एक बार बोला तो US गवर्नमेंट आके मारेगा मुझे. C5? C5? C6? Okay, good. D1, D2, D3, D4, D5, D6. Very nice. Shubho, what's your number? F6. Okay, fine. Shailendra, given that he has got a project presentation, can we schedule him earlier? Shubho, F6. Okay, fine. D6 is here, right? Yeah. E1, E2, 3, 4, 5, 4, 4, 5, 6, G1, 2, G2 नहीं है, G3, G4, G3, G4, G5, G5, G6, okay, H1, 2, 3, 3, okay, 4, 5, 5, H5, 6, I1, I2, I3, I1, was there an I1? Not here. 2, 3, 4, 5, 5, 6. Okay, so those who are not here will have to give me a strong justification why they need an E-certificate. If I have to be like with my students. Anyway, no worries, let us start. I'm hoping that they'll all join in. If you do have the numbers, please let them know. And we would really like to do this because it's a good exercise, and Amrit and Anshuman are here, they can give you very good feedback. So in case you happen to have the numbers of your compatriots, please do call them. Thank you. So let's start. Shailendra, are we ready to go? We need 5 minutes? 2 minutes more. Okay, we need 2 minutes. All right. So I did a roll call. If anyone is here whose name wasn't called, or whose name, what was your D? B5, okay. Ashish is here, good. Yes, there was a roll call. Anybody else I didn't call in the roll call? Okay, all right. While Shailendra gets set up, just another housekeeping business. So hopefully we'll be done by tea. So tea is at 4 o'clock, 3:30? I think it was 4. Whatever the time, I guess. $3:30, yeah. So PK will be here at around 4:15, and he would like to have a brief chat. And once our talks are done, then he will have a chat, and then I think we'll move to closing the session. So that's the basic idea. Okay. Are there any other questions? Are there any other administrative issues that we can deal with while Shailendra gets ready? Yes.
Can you just announce it?
Yeah, please. Yeah, you can go, Mike.
Just a request, those who received emails about partial travel grant, they are requested to kindly fill the form. Prem, can you please stand up for a minute? Yeah, so you can see there he's having some forms with him. Please only submit those bills which would account for the travel grant which was mailed to you, so that that can be reimbursed. Anything above that we may try, but it's less likely it will get through. But yeah, please ensure that the forms are filled. That will really help us in case anyone missed. Those who are already filled, thank you very much. You missed, Prem. Yes. But only one bill, then we can only pay for that one bill. All the names are there, 3. Any one can submit, and in other case, you can just say that it was shared. Okay, you can put any other bill in that case. Okay, between your house institute till here, home institute till here. Okay, thank you.
So couple of participants, what they are trying to do is, because on your onward journey to Chandigarh or elsewhere, you will not get the bill, or you will not be able to give it to us. You may hand it over to the taxi driver, and the taxi driver usually frequents IIT Mandi, so he can leave it in the guest house, and the guest house can then tell the strict office, and they'll come and pick up the bill. And you can keep me in the loop. You can say that the guest house, I talked to the driver, he has submitted the bill, and then I will tell them. So that is a possibility that you can explore in case, yeah, of course, keep a digital copy, yes. Because they are frequenting very frequently between Chandigarh and IIT Mandi. Shailendra, are we good? ठीक है.
Let's start it. I would like to call A1 team members to start the presentation. Let's start.
Hi, I'm Dr. Himanshu. So I'm working IIT Sri City. So my projects, I'm going to discuss about the game-based VR platform for school education. So the thing is, why it's not working? Like, can I? Yeah. Okay. So why? Okay. Okay. So why we need the XR for the education? Okay. So the problem is in the STEM education, it's basically practice and learning. Okay. It's not like, okay, you do in the theoretical 2D textbooks. So what we found in the schools, it's very difficult that they basically learn the physics, chemistry, those things in the 2D textbooks. So, and also they don't have any kind of lab environment. So we try to convert those things into the VR teaching platform where they can basically able to do the laboratory environments and they can basically do the spatial learning, okay, instead of having a textbook things. So if you take a analogy, right, like for example, if you think about the flight simulator, the pilot, right, they don't do its learn from the 2D textbooks or any kind of video learning, they basically do in the simulator. So we just want to do the same thing for the STEM educations. We are giving a VR platform, and based on the VR platform, they can able to learn those things. So we have done some kind of studies with the cognitive studies also with the EEG and the different school educations. We had done some tests for the different studies. So you can see, and all the studies basically says that VR platform is far better than the traditional books. Yeah, this is basically the ABT. So of course, why we need the end? Of course, the students want to learn the STEM education, okay? And of course, it's having the missing that component. And but of course, it's like 2D textbooks. It's not that able to give those things. And of course, lab, if we create some kind of lab environments, they can able to learn those things.
Thank you.
Therefore, we are just building it. That's it. Thank you.
Thank you. This is the title of my topic, is the catastrophic changes in coral reef ecosystem under different factor. We have considered macroalgal toxicity, elevated sea surface temperature, that is the most important thing nowadays, overfishing and invasion of predators. Yes, this is the brief biological overview and the importance of the conservation of our coral reef system. This is a diverse collection of species that interact with each other and physical environment. And there is a symbiotic relationship between zooanthelia and coral polyps. Coral polyps, they actually do not photosynthesize, but have a symbiotic relationship with single-celled organism called zooanthelia living inside the coral polyps. And the main cause of concern is the coral bleaching. It is the result of disruption of this symbiotic relationship between zooanthelia and coral host. And the main reason behind this coral bleaching we have identified is the macroalgal toxicity. We always know about the term HAB, H-A-B, harmful algal bloom. Actually, macroalgae, they release toxic chemicals which is harmful for the existence of coral reefs. And there are other reasons, that is overfishing And this is our mathematical model. And this is the effect of toxicity in the system. That is, when the toxic chemicals below this threshold, the system is coral and macroalgae dominated, and when it crosses some value, it is macroalgae dominated. Thank you.
Thank you.
Which one is the slide changer? This one, right?
Yeah.
Yeah. So yeah, it's moving. Okay. Good evening, all. So today we are going to see, are the microbes present in the cancer tissue and what they are doing there. So that's the core concept. So before going into that, I will have a deep introduction about what is microbes, because today we see everywhere, especially after the post-COVID era, everywhere they say the material, whatever they advertise, they say it kills 99.9% of the microbes. But in reality, I just make analogy of comparison of microbes to gods. Okay, so they are also invisible, they have no sex, they are omnipresent, they present everywhere. In all, even in extraterrestrial space, inside the earth crust, within our body, in all the organisms, microbes are there, and they are not just being there. They play a bigger role. They are the creators, operators, and destroyers. Even within our body, nearly 3% of the body weight is constituted by the microbes. And microbes are present in our oral cavity, in our intestine, everywhere. And now studies shows even internal organs have microbes, which is what the core of this study. Even the breast tissue, for a newborn baby, the first source of microbes is from the mother's milk. So that's why the formulated milks are not recommended. So in this study, what we have questioned is whether the sterile, there has been studies from Israel and other countries which showed microbes are present in the breast tissue, especially in the cancer tissue. Even in healthy tissue also, microbes are present. That's what I say, not all microbes cause diseases. They help us also. So our question is, whether they correlate with, during disease status, do they change, and whether they correlate with a condition called metastasis, which is spreading of cancer from one tissue to the other. So in this study, we have collected samples, tissue samples, and by genomics, metagenomic sequencing, we identified the microbes, and we have showed certain microbes are uniquely present in only those who have developed metastasis. So as a continuous follow-up, we are working on to establish this as a marker signatures which can help. I thank everyone. Thank you. Thank you all.
Good afternoon, everyone. I will talk about decoding seed traits, a tale of two crops. The two crops here being Brassica juncea, that is mustard, and sorghum bicolor or jowar. And using omics technologies, my lab has identified some genes and RNAs that are valuable source for breeders in biotechnologies to improve the seeds of these two crops. Now, seeds, we all know that we can visualize them as tiny factories which have a lot of economic importance, because be it cereals, oil seeds, nuts, or pulses, they are a source of proteins, carbohydrates, and lipids. And the challenge that we currently have is that because of increasing population and due to prevalent malnutrition, we need to improve the yield of the seeds and the quality of the seeds. So why is it a challenge to improve the seeds? Because seeds are far from the simple structures that they look like. They are genetically complex, and all of these seed traits, they are governed by complex networks. So we need to identify genes so that we can do genome editing and breeding. But is it a simple task to identify these genes? No, it's not. It's like looking for a book among millions of books, only without a catalog. So what we do here is, we do this kind of cataloging using these omics technologies. We profile the DNA, RNA, and protein so that we know which are the candidate genes that are regulating these traits. So this is the work that we have done. We grow the plants, we harvest the seeds at developing stages, we phenotype them, we measure the seed weight and the iron and zinc concentration and so on. And that is how, by correlating the developing seeds expression at the level of genes, their proteomes, and by correlating it with the phenotype, we have identified candidate genes for multiple traits, including grain size, starch, protein content, and various other traits. And we also make these databases. So this is our overall work where we have developed we have identified these candidate genes for developing improved cultivars. Thank you.
Good afternoon, everyone. Myself, Gaurav Chauhan from IIT Indore. So today I'm going to talk about the similarity between the image on the left, which is a salad dressing undergoing phase separation of oil and water, and the image on the right, which is essentially compartmentalization inside the cellular system. So what we see here are two kinds of compartments. The first one is the membrane-bound compartment, nucleolus. And membrane-bound compartments come about because of the presence of a membrane. But cells, as we are now observing, also have these membrane-less compartments, which come about because of phase separation of peptides and proteins and RNA. And they are very similar to how oil and water do not mix. Well, it turns out we can also have the proteins getting demixed and forming these compartments. And it is essential to study this because we want to understand the phase behavior, to understand cell biology, but also for biotechnological applications. And so essentially the way we characterize phase behavior is by using something called a phase diagram, which shows under what conditions do these proteins actually undergo phase separation. In our study, what we did was we looked at proteins called ANRFs, which were there in the root cells of plant Arabidopsis. And what we observed was that these dense phases, they showed this fast and directed motion. And so by using computational modeling, we tried to study, okay, what happens to our phase diagram if we have motility in the system. And so what we saw was that if we had this motility in our system, motility enhanced the driving forces for phase separation through this mechanism called MIPS. For more information, please check this out. Thank you.
Good job. Okay, thank you. So good afternoon, everyone. So in the world, there is an infectious disease that comes from the microorganism, small, tiny organisms. And if you take at that, there are 6 microorganisms. They are called as the top 6 microorganisms. And some of them acquire resistance. For example, some years before, when you give a rat poison, rat will die. Now if you give the rat poison, rat has developed resistance. Next day it will come and knock your door and ask for the poison again. So that's the strategy this microorganism is doing with your antibiotics, with your drug. So among them, there is one Acinetobacter baumannii, which is considered as a critical because it has a capacity to get a resistant at any point of the time. That means if you have a drug, give today, tomorrow it will get resistance. That's why the World Health Organization has categorized this as a red hot critical pathogen. Until the year 2000, it was silent. It is present in everywhere, water, skin, everywhere, but it was not that much causing disease. But now it has been considered as a multi-drug resistant, that means completely drug resistant. There is no cure things. So our idea is to check whether this microorganism from the environment, from your skin, how it acquires, is there the animal is being a source. That's the idea behind. So we went to the local region. We started collecting the microorganism from animals, plants, human, and environment, and we looked at the genome level, what kind of similarity is that? So we started looking at the genome level, we found that there is a connection, and we have did this. That means this microorganism is acquiring resistance from the environment and from everywhere, even the pesticides resistant everything. So we need to take care of controlling this microorganism. That's why the WHO has also given this into things. This is my group working different regions, collecting the sample, and with this I thank my team. My team consists of veterinary doctors, human doctor, and everyone. Thank you very much for listening.
I'm Jaya Nirmala from the Department of Computer Science from IIT Trichy. We are doing the project where legal documents or legal judgments are summarized, and why it is needed is we need to reduce the time that is taken by the lawyers and the judges to read through the documents. So what we did is, so we have what are called roles in a legal judgment, and these roles needs to be identified. Once these roles are identified, we can easily summarize the document. And why it is challenging is, we all know that legal judgments are more than 200-300 pages long, which is very tough. And also we have severe class imbalance, and full fine-tuning is not possible. So why it is needed, as already said, it reduces the time for the lawyers and judges. We all know that in India we have a lot of pending cases. So because the lawyers and judges can read them easily, we can solve the pending cases. So how we are doing it is, in the transformer layers, there are a lot of layers. So we find out which layers are dealing with the rare classes. For them, we give more power and more efficiency, and because of that, we are able to get the rare classes easily. And what is the analogy is? Analogy is, suppose the student is having 6 chapters in which the questions will be frequent, and 4 chapters in which the questions will be infrequent. He wants to solve, he wants to get more time to solve those rare subjects. So we give more power to those rare classes, and hence we are able to achieve this. So what is the and but together thing is? So and as rhetorical roles are important, but what is the problem is there is severe class imbalance. So machine learning models take more time and energy, but computational capacity is more, which is not possible. So we have developed an algorithm which uses PEFT algorithms to solve that. Fine. Thank you.
Hello everyone, my name is Nausheen Nazir. I'm from Squash, Kashmir. And today I would like, it's a totally different field as I see lots of other fields. So what I'm doing right now, I'm studying trees as living sensors, turning plant signals into the climate smart agriculture. So the problem is no longer water, it is the timing. The thing is that we have climate change, the trees are responding differently, and then we have to take the decision. So the question is, can we detect the plant water status early enough to change the irrigation decision? So as you can see that we can have the soil can look completely fine, but the thing is that we are measuring the environment, and what we need to measure is the organism, because the plant itself must become the part of the measurement option. This is what we are trying to find out. So I have started building a kind of sensing stack, which is not a single sensor. And where I'm trying to target the soil, the stem, and then I'm tracking the plant, how it is responding to different soil moistures, and then the leaf also, that how it is responding to those different irrigation levels. And the goal is not to get the more data, the goal is that I want to have a trustworthy decision for the farmer. So this was something the key breaking for my research, wherein I could find out that how the trees are responding to different moisture and how they're elevating their temperature. Then I came up with a score, the sense and the fuse and the score and the act. And the plant signal is useful only when it arrives before the decision window closes. And this in the orchard, the answer was not more irrigation. 80% I could reduce, and it was more like a practical way to increase the yield, water productivity without losing the quality of the crop. Then the next step is not that I'm here to look for another sensor. We have almost thousands of sensors are there. But the question is, I want to have a living orchard. And before I leave, I want to collaborate, that I want to have a plant biology with me. I have the orchard, I have the biological question. The need is that I want to build a system that is intelligent enough that we can give farmer where he can respond even the climate, before the climate uncertainty prevails. Thank you.
Okay, good afternoon, everyone. Have you ever wondered in a noisy environment how you are able to talk to your friend? So in a noisy environment, for example, if you have so many people talking, like if you are in a restaurant, so you are trying to communicate with your friend. So how is that possible? So the main thing what we have to think in this particular aspect is combination, to your ear is a combination of all the sounds. But our auditory system is smart enough to actually understand how that is happening. So in other words, it's able to segregate the target speaker. So, but on the other hand, if you bring in an aged person, so what happens is that in that scenario, the aged person will say that, can you repeat again? I'm not able to understand. So this is exactly what we are trying to do in this work. So what we do here is that we try to extract the neural representation in younger adult as well as the older adult. So to start off with, the main important point here is, can they hear it? Yes, they can hear it, but how it is represented neurally in the brain, that is a very important aspect. So, and then the key message which I am going to convey is a reduced P300 amplitude is actually contributing to a lower identification scores in older adult. So what is the metric? Metric we use is P300, which is a measure of frequency discrimination. So I'm just going to go through quickly about the results. So what happens is that we put a EEG cap to our subject, and then they have to do specific tasks. So as we increase the F0 difference, what happens here is that the P300 peak actually starts to emerge. So that is a very important aspect. That means that the P300 is playing a role. Then, more importantly, in terms of the age aspect, what is happening is that the P300 is actually reduced in terms of older adult with normal hearing as compared with younger adult with normal hearing. Okay? All right. Thank you very much.
Hi all, myself Dr. Saisri, ANRF NPDF from CSIRNS Trivandrum. Today I'm here to discuss about personalized precision health intelligence. As we humans, we all achieved extraordinary achievements in the field of space exploration, technologies, and even medical field, but we struggle in the areas of lifestyle diseases, such as obesity, cardiovascular diseases, and even cancer. Do you think why? Because most of these diseases starts its journey in the early of 20s and 30s, but the symptoms arises only after 50s and 60s. So when we reach the hospital after symptom arises, it is already grown to a major stages. So how we can resolve this issue? If we have a technology where we can continuously monitor our health system, so we can move from a reactive care to a precision health intelligence. If you think, how is it possible? Yes, it is possible through a simple technology, electrochemical sensors, where it can detect the biological signal transfers to the electrical signal, and we can get the data. So we can use the medium sweat or tears, saliva as the biological medium to provide this biological signal, which can be transferred to the electrochemical signals. We can use multimodal analyte systems also through a possible flexible substrate also. And we can use this data system for AI predictive modeling so that the micro anomaly detected even years before can be used for the prediction of disease in the later stages. And the data journey started with recognizing the analyte signal, transfers to the smart devices, which can be transferred or store the data to the cloud databases, which can be further utilized for the periodic monitoring of ourselves and by the doctors also. So here we are trying to develop a smart intelligence health directory using the data accumulation and storage in the AI platforms and cloud storage devices. So that is personalized precision health intelligence. Thank you.
Okay, myself Biplav from Scottish Church College, Kolkata. Today I'm going to tell you about the story of how tiny chromosomes can tell whether the crop relatives are important to breeding. As we know, As we know, the vegetable crops are losing resilience over time due to infections, and brinjal plants are devastated by border infection. So we need to see which are the wild species which are very closest to it, like the siblings, and which can be the cousins of it. So in order to do that, we first need to know the chromosomal basis of characterization. We need to look at the ploidy and the karyotype and the chromosome number. So for that, what we have done the enzyme-based elimination of the plant cell once and visualize the chromosomes. And we have come up with data like the progenitor species has been found to be closest to the wild one, or to the cultivated one, while the wild species are far distant than that. And so with this, we have come to a conclusion like Insedum and Melongena, which are the closest in the gene pools, can be considered as the siblings, and the other species in the loop can be considered as cousins. So in order to develop improved breeding strategies, we need to first figure out the chromosomal relationship. And with this, we have further questions to solve, like what is the genomic complexity, what is the genome size relationships among these taxa, so as to develop the present breeding scenarios of eggplant. So with this, thanks.
Good afternoon, everyone. So today we will understand like why this load sleep actually repels the water and how can the water strider easily, comfortably on the water. So if we go into the structure of the load sleep, it is found that it is not only a smooth surface, but it is made up of some rough structures, and those rough structures are made up of micro and nano textures, which are further coated with a wax-like nano coatings. And together with that wax-like coatings, this provides this water repellent property to the lotus leaf. And it has been designed that in order to fabricate these surfaces artificially, so we need to obtain these two criteria. So in this work, we have designed these super hydrophobic surfaces, which are not repellent only on the surface, but if we go into the deep of the surface, it still repels the liquid droplets. And when we coated those
these super hydrophobic surfaces on different substrates like fabric and the cotton, you can see that it still shows that super hydrophobic, that's water repellent property. And that was further used for separating the oil and water mixture. So you can see here this substrate is not only super hydrophobic on the surface, but if you tear it into the pieces, it still shows that super hydrophobic property. And then we can selectively separate the organic solvent or any oil from the oil-water mixture. Thank you so much for your attention.
Hi everyone, good afternoon. I am Tanzila. I'm a Ramanujan Fellow at the University of Kashmir. So I am going to tell you a little bit about a project that got published last year. Well, that's blocking it, but it's prenatal nicotine exposure rewires the developing brain. I'm a developmental neurobiologist by training. And this is where the work was done as my part of the postdoc work at UCSF. So what we found actually in this paper is that nicotine, which has very clearly passes the blood-brain barrier and also the placental barrier, how nicotine actually, once exposed to, say, neural stem cells, the radial glia, the stem cells which give rise to neurons in the brain, how they actually respond to nicotine through the nicotinic acetylcholine receptors. And we found that with nicotine, there are more stem cells, and this happens at the cost of neurons, and that could also maybe be a potential mechanism why after nicotine exposure, the cortex actually becomes thin. So we mainly focused on two receptors, CHRNA7 and CHRFAM7A, and it's important because almost 10 to 15% of pregnancies worldwide, they still involve nicotine exposure. So mothers, they smoke during pregnancy. Again, as I mentioned, this is linked to smaller cortical volume as well, leading to learning deficiencies or ADHD, these kind of behavioral problems as well. And again, understanding the mechanism was our first step to understand what could be leading to this cortical volume reduction and plus interventions. So we prioritized, we used a range of molecular and phenotypic analysis. We did receptor mapping, we did functional tests, we do a lot of transcriptomics in my lab as well. And we also did rescue experiments. So we combined all these different models and found that there was this YAP1 gene which actually controlled the progenitor to neuron balance, and this could actually be a pharmacological target. Thank you.
Hi everyone, my name is Shubhabrata Moitra. I'm from Ahmedabad University. So I believe we all are familiar with the disease called asthma, right? Why is it so important? Because currently in India, approximately 42 million people are suffering from asthma, both including adults and children. And this accounts for a significant out-of-pocket expenditure every single year. So for example, in 2015, a report came out that suggested that approximately $9.63 billion were the out-of-pocket expenditure only because of asthma. And that does not take into account any insured hospitalization or anything like that. So out of all those asthmatic people, approximately 25% of all asthma requires at least one hospitalization every year. And out of that 25%, 40% require a re-hospitalization within the first 1 month to 3 months post-discharge. So that means when they are discharged from the hospital, they need a second hospitalization within the first 1 to 3 months. And why is that? Because when they are discharged from the hospitals, most doctors fail to give them a proper plan how to control their asthma, what kind of attributes they need to focus on to reduce their asthma-related attacks or anything like that. So what we exactly want to do, the project has 3 phases. So number 1, we want to develop an asthma care plan which will be given out to the patients by the physicians at the time of discharge. So we are going to develop a complete care plan, and So this is the developmental stage, and then we will do a pilot study to see the feasibility, and then we are going for a full-scale clinical trial. And what we expect that this asthma care plan will help reduce readmission, and will also provide the patients with a better quality of life and ultimately lower the resource use. So thank you so much.
I would like to call Dr. Subhopal first, as he have to leave. F6 is our team.
Okay, so apology for breaking the queue. And yeah, today I'll be talking about my last year awarded PMECRG project that is on the data-driven observability enhancement of the power distribution network. But why we are more concentrated about this, why I have chosen this work, is that if we are successful of doing this work, then we can promote more and more renewable energy integration that may be in the form of rooftop solar, and will align themselves with the notion of the country, where the PM Prime Minister already announced about the PM Surya Ghar Yojana, PM Kusum Yojana, where we are trying to obsolete with the thermal power station and moving towards the solar power generation. But what is the problem with this technology? Because if you see that whenever you will integrate a solar power panel at your rooftop, are you asking your utility that you have installed a 2 kilowatt or 3 kilowatt of rooftop solar panel? No. We just install it. We just want to do it. So we are getting subsidy and done. So, but we are not seeing that how much pressure is coming on the utility side whenever you are not using it. For example, let's say whenever you are not at your home, let's say currently, what you are doing, you don't have any control on your weather. So the entire solar power is going back to your utility grid, who is supposed to give you power, now getting power. So that challenge actually we are trying to solve, that how to deal with these challenges, because now we are installing more and more sensors in the network. So if you use some data-driven technologies integrated with AI ML technologies, so if you use this, can we see that how the distribution network can respond with your solar power penetration? Or if the customers are not behaving right, then at that time, how my network utility, as an utility, I can do a proper thing that the customer can still get the power, or the customer will not affected, as well as my utility grid will not getting affected. So that is all about the project. Thank you. And if you want to more details, so you can visit my lab website and check out. Thank you.
We start with the D5 or E5. Yours? D6. Sorry, D6.
Good afternoon, everybody. Myself, Dr. Subhankar Samanto, wish to present my research work entitled Fast Mechanochemical Oxidative Lactonization Towards Bioactive Phthalate Analog. Actually, I am coming from that of the college, so the facility is very limited. For that reasons, we have designed a apparatus that can be converted the fruitful product, which is not harmful to our environment. So we are going to that of the what is the conventional synthesis. In the conventional synthesis, there are different. In the conventional synthesis, in the conventional synthesis, actually there are different type of the procedure has been used. That is the toxic solvent, toxic chemicals are used. But these chemicals are indirectly affect to that of the drainage water and food chain systems affected. So we want to design a sustainable way where the molecules can be synthesized by the reductions of the solvent, and we can use the harmless chemicals. For the reasons, there are different type of the techniques has been used for the synthesis of the lactone derivatives, such as the microwave, electrochemical, and the light promoted technique. But our synthetic methods is that the only the mechanochemical synthesis. Here the starting material can be converted to the product by the simple of the reagent by grinding the substrate of the reactant, and we get the desired product. And the different type of the methodology has been happened in that of the one vessel, and we get the desired product. So we want to these are the bioactive molecules, and we can also reduces the E factor for these reactions, and E factor means the heterogeneous is very much reduced, and to get the desired fruitful product. And these are the methodology. We have also used our molecules is very much fluorescence in natures, and so we can use for the detections of the moistures for any samples by fluorimetric methods. And these are the fluorimetric method, and where the molecules has two form, one is the ketone and the enol form, and from this calibration curve we can calculate the amount of the moistures in the organic samples. And hence this methodology is the domino reactions, mean most reactions can be happen in one pot, and the cost effective and autonomic. Thank you for this nicing of this listening of these presentations. Go green with that.
Dr. Pradeep.
Good afternoon. I am Pradeep Kumar from IIT Vellore. So basically, using light for breaking and making of bonds, it's again the sustainable organic synthesis for the fine chemical synthesis and also bioactive molecules. Right? Yeah. So the light can build medicines favorite molecule. So we have used the blue LED, and with the red dye is a red dye to do the organic transformation like CN bond formation. So here we have achieved the guanidine, which is a tricyclic nitrogen-based compound, tri-nitrogen-based compound, which contains most of the FDA-approved drugs. So here, what we overcome, as I mentioned, you sustainable organic synthesis. So I'm using the light with the green solvents, and also like in the mild temperature. So one can achieve various FDA-approved guanidine-based codes. So some of the FDA-approved drug, finasteride, it's a blood pressure drug, and even many other FDA-approved drug core molecule can be achieved through this strategy. So what we have overcome, why it matters. So this toxic metal can be replaced, and also it is waste minimized, and atom economy is very high, which is which is also applicable for the green matrices. And here, as I mentioned you, we are incorporated urea and amine, so that under LED and rose Bengal condition is the photocatalyst. So it is going to giving you the product, and also the sulfate is going to be the 5 product, so which is atom economy, and also which is low waste generated during the reactions, and it's a mild temperature, and the broad substrate scope can be developed. And besides, so again, based on the morning session, I used that format, which is giving you the very clear output, so anyone can understand. So again, think of Rose Bengal as a tiny solar panel. So this is the Rose Bengal as a catalyst. So where the light energy blue LED is going to be meet upon the Rose Bengal. So thereby bond breaking and bond cleavage is happening. So again, bond breaking, it cleaves. Then wherever the energy matches, it is going to have the radical swapping, and the desired bond can form. It's going to be the new CN bond. So overall, it's guanidine, sit at the heart of many life-saving drugs. And
hello.
Yeah. Yeah, it's the overall. Thank you. The morning is very, very impressive, and anyone can easily follow up. Yeah, thank you.
there.
Dr. Venkatesh.
Slides in there. Slide will change. So, good evening all. Myself, Dr. Venkatesh, Associate Professor in Mechanical Engineering Department, IIT Warangal. So, my project is related to performance enhancement of orthopedic implant using rotary ultrasonic abrasive flow machining. I worked in both product development and as well as process development. So, the major need of advanced finishing is, particularly in orthopedic implant, is to improve the corrosion resistance of implants and also to improve the functionality. So our target is actually to achieve 0.08 micrometer of the orthopedic implant finishing using rotary ultrasonic abrasive flow machining. Why only rotary ultrasonic abrasive flow machining? Because we required some particular process for finishing complex geometry. So we can finish simple geometry, but we cannot finish a complex geometry like this. So we are working on developing a new setup for finishing the complex geometry and reaching micro to nano level finishing, where we improve the functionality and as well as reduce the corrosion, improve the corrosion resistance and all. So we developed a product which is flexible in nature. Actually, this is the tool we are using, which is flexible. It is made up of abrasives mixed with polymer gel. So we pump to and fro using extrusion pressure, and then we try to finish the complex geometries like implants and other automotive components and other very complex materials, etc. In process development, we observed that simple AFM, simple abrasive flow machining, is having some problem. So it is suffering with low finishing rate. Then we developed process by hybridizing it by vibration and by rotation. So majorly we hybridize the process with flow, vibration and rotation. The overall breakthrough is AFM provides a flexible media and the complex surfaces can be finished, and the rotary ultrasonic abrasive flow machining is the final achievement. And the final achievement is we applied a patent, the patent is granted, and we are working on technology transfer. Thank you. Good evening, everyone. So I'm Dr. Amrit Vatsa from IIT Warangal. So in our laboratory, we are working on rongalite as a C1 homologated. This homologation means we are introducing one carbon to the existing molecule in order to improve the efficacy of the pharmacophores. So in the literature, we have several C1 homologated compounds. One of the best reagent is formaldehyde. All the formaldehyde works very, very good, but the thing is, the formaldehyde is a toxic. If the person exposed to the formaldehyde, they will suffer with the different diseases. So that is why there is a search for the new reagent which can give same functionality with the environmental benign nature. In the literature, we found that rongalite, an industrial reagent, its cost is 1 gram, 1 rupee, so which can be served as a C1 homologation. In order to test whether rongalite is acting as a one carbon homologation or not, we have conducted one reaction, and the results are tabulated in this table. And fortunately, this rongalite is reacting with our required compound in ethanol to get the 90% of yield. And by using this same protocol, we have applied the C1 homologation to functionalize all the heterocyclic compounds which are acting as a good biologically active pharmacophores. And in the literature, so many methods are there that can incorporate CH2 unit into the required molecule by using a transition metal. I would like to introduce a same C1 homologation without using any transition metals. So this is the mechanism. You can see you can take any sp2 hybridized molecules. So you can mix with rongalite to get the C1 homologated product. Thanks to the today's speaker, because of them, I can able to make my
abstract in a simple and subtle manner. And thank you very much.
So good afternoon, everyone. I am Dr. J. Yogapriya, working as a professor in Konganadu College of Engineering Technology. I am an ANRF grantee. I am going to develop an AI-driven PCOS kit. So normally, infertility is the major cause of concern in all over the world. There are 27.5 million people are infertile couples in India, as well as for the reason for infertility is many reasons, that is PCOS, infections, fallopian tube blockage likewise. Among the women reproductive age, PCOS is the major concern. So PCOS usually occurs due to that is hormonal imbalance. So usually in pituitary gland, the gonadotropin, that is hormones will be induced through that the pituitary gland. Follicle stimulating hormone, luteinizing hormones will be generated. So this FSH and LH plays a major role in order to make the egg to come from ovary through fallopian tube to uterus. So whenever the fallopian tube, that is follicle stimulating hormones levels, everything is normal, means it is normal menstruation cycle. And if low FHS means and follicles do not grow, and also a high LH means that is more androgens will be produced. There is an AMH values also will be high. There is an polycystic ovary conditions. So usually in order to identify the PCOS, most of the village women or most of the must have to go for a hormonal clinic wherein they have to give the blood and they have to test it. It costs around 3,000 to 4,000. So in order to continuously monitor the hormone levels, we need a low cost PCOS kit in which we can easily analyze for the weekly, 2 days, once, everything we can analyze it through this PCOS kit with the amount of 150 rupees. But if you are going for higher cost, it will cost around 4,000 to 8,000. So we have reduced it by using a normal finger prick samples we have taken, and through the graphene-based SPE biosensor, it is the antigens, reagents will be mixed. Through that, the values will be displayed. Here we are having an AI-driven approach also. The gynecologist can see the values of that is all the hormone levels easily through our kit. So we have driven the user interface screen for easy accessible. And also we have gotten this type of kit will be there reduced, and also we have developed an Yoga Fly technology startup have been registered through TBIT. So the kit is set to come.
Thank you, ma'am.
Thank you.
Thank you.
So through morning session, we have analyzed like this. Thank you. Thank you.
Forward, backward, point.
I don't have your file. Can you go for this one? F4, you can come. 1 second. F4. I don't have his file, by the way.
Already started.
You can start.
Hello everyone. I am Debashmita Dotto, kindly working as a Ramanujan Fellow at IIT Kolkata. Today I would like to present my ANRF funded project, Therapeutic mRNA Vaccine for Cancer Treatment. At first I would like to thank ANRF and IIT Mandi for this wonderful opportunity. Nowadays, whenever we talk about mRNA vaccine, it first reminds us COVID-19 pandemic situation. However, mRNA vaccine has its own history. After the discovery of mRNA in 1960s, hundreds of scientists worked for decades on mRNA vaccine before the pandemic situation happened. But after pandemic, we all realized the magical potential of mRNA vaccine in saving billions of lives. So for our project, we hypothesized that an mRNA encoding a tumor antigen of interest, if it can be packaged using all these lipid and ionizable lipid and other cholesterol, these molecules, in a LNP system, alone or in combination with adjuvant, which actually acts as a catalyst to boost up our immune system, it can specifically kill the cancer cells. So I can briefly explain how it can do. So the lipid nanoparticles can efficiently deliver its packaged mRNA inside the dendritic cell, and after translation and the tumor antigen processing, the dendritic cell can express the tumor antigen on its surface to educate T cell, so that the T cell can proliferate and generate the tumor antigen specific immune response in tumor microenvironment. So this work will pave the way for developing therapeutic mRNA cancer vaccine platform in India with personalized new antigen specific therapy and ultimately saving patients' lives. Thank you very much for your kind attention.
So good evening to everyone. So myself, I am Professor P.K. Praveen Kumar. So going to present on the effect of plant-based compounds from ashwagandha on treatment of hepatocellular carcinoma. The innovation of this project is actually we go with targeting not simply with the nanotechnology, but also with the mitochondrial targeting technology. So we actually, if we go to the next slide, you can able to see. So in the liver, you can able to see in this part, you can see the abnormal tissues are proliferating. So in this region, we can find much of mitochondrial when compared to the healthy sites. So our purpose is not simply wasting the drug in targeting the healthy sites, but our purpose is to target only the diseased tissues. So the mitochondria, the energy storage will be present more. So if you see the hepatocellular carcinoma, this is the primary liver cancer, and it accounts for nearly 6th most common cancer occurred. And these causes are just because of the hepatitis B virus, C viruses, and also because of alcohol consumption and smoke. So if the main objective is to reduce the side effects using the herbal drugs, and we conjugate with the mitochondrial targeting regions, as well as we nano-encapsulate the drugs, so that we specifically target the desired sites. So if you see this in the middle region, we are showing the mechanism of action, and we also tested in vitro and in vivo studies of plant compounds with the target. The target what we have chosen is heat shock protein 90 and heat shock protein 75, which is a mitochondrial protein. Actually, our objective is the targeting just like a guided missile system. And we already worked on in silico, and also we worked on in vitro and in vivo. The address is this caps. Okay. So thank you for ANRF and IIT Mandi for providing me an opportunity to present on this research innovation. Thank you.
Thank you. I would like to call candidate F3, Mr. P. Malay.
Yes, good evening to all. My topic is assessment of groundwater quality and associated human health risk for the lower Ponaya River Basin. So water is essential for a human being, not only human being, industries and agriculture. Without water, we can't survive, we know very well. So I received the project from ANRF. So groundwater is essential for human health, but nowadays the groundwater contamination is huge, especially the children are using the more water in urban areas. So fluoride contamination, nitrate contamination is a huge. So if they are used means, so what are the problems we are facing? We are showing the map format. So around 105 groundwater samples we are collected from pre-monsoon and post-monsoon season. So pre-monsoon and post-monsoon collected samples based on this methodology. Physical parameters, major cations and anions we are analyzed. Then we are analyzed from the bore wells and the tube wells, so like that. Then after the sample collection, we are analyzed. The analyzed information, pre-monsoon and post-monsoon season, excellent, good, poor, very poor, like that. Then unsuitable for drinking purpose, like that. We are prepared. The maps also we are prepared, which one is a good, poor, very poor, like that. Then the same water used children, women, men, how they are affected. Maximum children only affected compared to women and men. So government concentrate where the fluoride contamination is huge. Government restrict how to solve this kind of problems. So these are all for our recommendation. So precision and crop rotation is essential. Then RO and then ion exchange, biological DNA interfigation is also essential. Thank you.
मिस हो गया क्या? ये क्या हुआ?
microreactor heterojunctions for electrocatalytic water splitting purpose. So where we are, as we know, there is a large demand is going on for the hydrogen generation, so which requires early abundant, earth abundant materials. So here we are focusing where we are targeting choosing some metal oxide clusters along with the layered double hydroxide materials, which we are combining them, which can be found in the nature, that is diatoms, which can be made their cell walls by using a polyamides, which are responsible for the making the cell walls in the presence of multivalent anions. So at under aqueous medium, at neutral pH conditions. By inspiring from this bioinspire process, we have developed a bioinspired assembly process where we have specially confined these polyoxometallites metal oxide clusters and LDH materials within the microcapsule structures, and we combine their hetero interfaces and tuning their electronic properties. And further, we have utilized these materials for overall water splitting, and we found that the initial materials are active for that water splitting, and further we are optimizing their structures and also at external parameters, and we are well characterized, and so the structural conformations and further dealing. Okay,
thank you, Dr. Rakesh.
Good afternoon, everyone. My name is Dr. Keshav Sharma, and I am working as an ANRF National Postdoctoral Fellow at CSIR IIT Hyderabad. So I want to collect water samples from various water bodies like rivers and ponds, put them in a sensor which I'll fabricate, and check whether they have forever chemicals or not. Speaking of forever chemicals, they are a huge class of per and polyfluoroalkyl substances, which are generally used in major industries. They have a very strong carbon-fluorine bond, which makes them persistent in the environment. So, and they are known to cause drastic changes in our body. So their detection is very important. So I'm working on two-dimensional mamexine and graphene-based materials, and so that they can selectively capture these PFAS, and we can detect them using surface enhanced Raman spectroscopy technique on the spot. So I'm working on this fabricating 2D sensors. I think I finished early. Thank you.
Forward, backward, front. Mic.
Okay. Shall I start? Okay, fine. Good afternoon, one and all here. I'm Dr. Mahima. I'm an ANRF and PDF at SCS, IIT Mandi. So basically, as we all know, that solar energy is a very abundant source of energy, and using smart materials which can use solar energy as a stimulus and to store the energy. That is the we can give the stimuli to that molecule to release the energy as per our demand. Here, the mechanism of the working of the photoswitches has been shown. What are the different molecular engineering can be done, different stimuli can be used, has been seen, and the mechanism of this photoswitching and the energy storage, which is generally known as the MOST, molecular solar thermal energy storage, is shown here. Here, the important and interesting part of my work is that many MOST photoswitches has been made, but we have combined the LC material. Here, due to lack of the time, I'm not discussing what is LC, and here are some brief application has been shown. So basically, many MOST material has been known, but they are basically working in the UV. UV is already, they have phototoxicity. And if we want to use the visible light, which is the actually, which consider majority of the solar spectrum, we need to develop the visible light photo switches, integrating LC material for the application in the most. So thank you very much. Here is the beautiful campus of our IIT Mandi. I hope you enjoyed your stay. Thank you very much.
Hello everyone, I am Shantanu Roy, ANRF NPDF at IIT Mandi. So I am a synthetic organic chemist. Basically I can make molecules. So it is not working. So basically I am working on the pyridine heterocycles. So you can see the pyridine moiety, it holds the 87% drug molecules according to the FDA. So right now the evolution of pyridine functionalization, it is increasing day by day. So now there is many challenge to functionalize the native pyridines. So you can see if you want to functionalize the pyridines, you can end up with the mixture of product like C2, C3 and C4. So basically you want to do the C4 functionalization of pyridines, but the thing is that researchers already overcome this thing by installing the blocking group. You can block here and you can get the C4 functionalization. There is need of two steps like functionalization of blocking group and then the removal of the blocking group. So there is many headache. So you want to propose, we already proposed this idea, we can install one radioactive handle and then we can activate this thing pyridine heterocycle by electricity, and we also wanted to activate these hydrocarbons, and we can in the intermediate will generate, and we can stitch two intermediates to get up this product. And these are the deliverables. And once optimization done, then we can do the scopes, and we can deliver the products with the medicinal chemist who can probes for the biological activity. Thank you, everyone.
Dr. Abhishek.
Chandra. Good afternoon, everyone. So I am Dr. Shuchandra I am a postdoctoral fellow in IIT Mandi. So today I want to give a brief essence on thermoelectrics. And what is thermoelectrics? Thermoelectrics actually refers to a material or a device which actually converts the waste heat to electricity. And you can see from this figure that we all know that almost 66% of heat is wasted. It is wasted in a form of energy. So in thermoelectrics, we actually can convert this waste heat to electricity, and we can apply this electricity to variable resources. So the importance of this material or this technology is very essential for our today's world, which is very much dependent on the electronics. And you all know that the the efficiency parameter of thermoelectrics is actually designated as the figure of merit ZT, which depends on Seebeck coefficient, thermal conductivity, and electrical conductivity. But the bottleneck is that three parameters are interrelated through each other. So we have to optimize the ZT of the material to enhance the performance of a thermoelectric material. So how can we enhance the parameter? Actually, we have to engineer both the electronic and thermal transport of a material. So the takeaway point could be that we can engineer both thermal and electronic transport of a material to enhancement. And one of the applications you can see that it can be used as a wearable device, thermometric device. We can think about the watch, the wristwatch, which can actually sense the body heat and convert it to electricity. So thank you. It's my presentation. Thank you for.
Professor Amit.
Forward, backward. Good evening, everyone. I am Amit from IIT Vellore. So at this moment, the cosmetics are tested using animals in majority of the world. But at the same point of time, I would also like to tell that majority of countries are now searching for alternate methods to test cosmetics, because cosmetics have lots of products which can be, I don't have to put that. Yeah, thank you for the concession. Yeah, so cosmetics have lots of ingredients which needs testing, toxicology testing as well as safety testing, maybe irritation or sensitization. So majority of world, many countries have now banned use of cosmetics which have been tested on animals. For example, India also has in 2014 banned cosmetics which have come from animal testing. So now we are developing alternate methods so that we can test cosmetics in lab on human relevant samples. So in this project, we are making in vitro skin models, meaning that we are printing skin cells to make artificial skin, or we can say human skin substitute. On that platform, we can test cosmetics, whether it is safe, what ingredient it has, whether the component, nanomaterial component of the cosmetics are crossing the cell membrane and causing any harm. So with this platform, we can test cosmetics in lab and on human samples, not on animal samples, because animal skins are different from human skins, whether it is melanin content, whether it is hair, the thickness of the skin. So it is better to test cosmetics on human relevant samples and human skin substitutes. So you can see that there are lots of side effects of using cosmetics, allergies, inflammation, and so on. So we are making in vitro platform by using technique called 3D bioprinting, where we print skin cells along with some soft materials so that it acts like a skin, it acts like a skin barrier function, and where we can test cosmetics. So that's all from my side. Thank you very much.
I would like to call candidate I5, Joydeep.
Is this a change forward, backward, point?
Good afternoon, everyone. So in today's presentation, I'm going to talk about our work, that is how to make a mathematical model for modeling of an ornithopter wing. So what is an ornithopter? Is a biomechanical version of a bird which can fly like a bird, and at the same time, it's actually an artificial drone. So to do this, we need to first look at the type of the wings. It's not rigid, but it's flexible, and we need a mathematical model to do that. So to make this model, we take the analogy from the bat's wing. So what it contains is a leading edge spar and the surface of the wing
and we put a spring on this to mimic the flexibility. So this is how a bat wing looks like. It is pretty much like the hand of our, the fingers of our hand, and it is stretching a membrane, and the membrane is slightly elastic. So this elasticity is modeled using the spring, and we have put this using a mathematical model, and we write the equations of equilibrium at the nodes 1, 2, 3, and 5. And this is how the loading on the wing takes place. When the wing starts to flap, it generates a load, and based on this, the wings deform, as our equations are showing. These are the deformations. And we have also validated it with our experimental results, and they have shown a good amount of match. So with this, we can make very efficient drones. For example, birds can fly miles without refueling and flying effortlessly for very long hours. And that can drastically change the way we make drones nowadays. So with this, we can reduce the power consumption to something very low as 40 to 50 watts per kilogram, so which is drastically less than a traditional multi-rotor vehicle. So this is the paper from which this work has been based upon. Thank you.
Now I would like to call candidate I2, Dr. Abdul.
So, good afternoon, all of you. Myself, Dr. Peer Abdul Hasib Shah from University of Kashmir, Srinagar. So, I'll be talking about modified azole antifungals, synthesis, physicochemical properties, and antifungal studies of new solid forms. So, as most of you must be knowing that there is an antimicrobial resistance, and this resistance doesn't only happen in bacteria, but was also discussed earlier in the day. But you can see this antimicrobial resistance there in viruses, in fungi, in parasites. So what we are specifically focusing on is the antimicrobial resistance in human pathogenic fungi. So the problem is that existing antimicrobial agents decline in effectiveness, and infections become more and more harder, particularly for clinicians to contain. So what we are doing is that we are working on the resistance mechanisms, and one of the mechanism approach we are adopting is the development of modified azole antifungals, which is a economic and green synthesis process wherein we are taking the help of the chemistry personals. We are developing the co-crystals of already known antifungals. So we don't have to synthesize new molecules. It's a time-saving process wherein we have been able to develop few other antifungal molecules. And they have very good physicochemical properties. They have enhanced its solubility, enhanced its thermal stability, and they could show good antifungal activity, and at the same time, they were not toxic to the human cell lines. To summarize this, we have been able to develop fluconazole and ketoconazole co-crystals that show enhanced properties and were not toxic to the human cell lines. So these can be preferred as an alternative to parent drugs, having better efficacy, bioavailability owing to their increased solubility. So thank you all.
I would like to call Dr. Ashish Ghosh.
Okay, good afternoon. My name is Dr. Ashish Kumar Ghosh from CSIR Central Institute of Mining and Fuel Research. I'll be talking about a benchtop system that we have developed indigenously for predicting the invisible fire arising due to spontaneous combustion of coal, thereby working for the safety of a coal miner. So this is a picture of our laboratory, CIMFR, established in 1946. And like IIT Mandi, our laboratory is also surrounded by hills. But if you look at the top of the hills, these are not fog. These are fumes. So the overburden dump surrounded by our laboratory. And if you also look onto the roadside open cast mines, you can see that those are the spontaneous combustion affected coal stockpiles. Now, this process, ये प्रक्रिया केवल सिर्फ खदानों तक सीमित नहीं है. जब जब कोयला को स्टोर या ट्रांसपोर्ट किया जाता है, then coal interacts with aerial oxygen, and in that course, due to the intrinsic nature of coal, heat may build up and it may catch fire. So basically, it affects the economy, safety, and the environment. So over the years, me and my colleagues have been thinking whether we can predict this fire before it occurs. So we could do it successfully by developing an indigenous device, which is a tubular reactor. And when coal is fed into it and temperature is raised according to constant rate, then a time versus temperature profile is obtained, where the black line denotes the temperature of the bath and the blue wavy line is the temperature of the coal. Okay, thank you so much.
Thank you, Dr. Ghosh. Now I would like to call candidate E1, Dr. Ravi Narayan Sethi.
This one slides forward, backward.
Very good afternoon to all of you. Myself, Dr. Avinaran Sethi from IIT Sarang from Odisha. My research topic is intelligent condition monitoring. So basically from the mechanical engineering, wherever we found that any type of machine is going to run, how to detect it, and earlier it will going to catastrophic failure, we're going to detect. That is the objective of this my topic. So objective is we have to maintain any time mechanical engineering, we have to maintain it, then we have to identify the fault, then you have to detect it, and we have to reduce the detection, that defect. That is our objective of any mechanical things. So how we are doing in the research work, we have to make one laboratory testing so that we are having general database system in our laboratory, then we implement in a current scenario of any type of component in a company. That's how in this project, what I have done it, I simulated very easily by relative dimension, relative vibration, so that easily you can make a simulated model for any type of equipment for the mechanical engineering. So this is the one artificial intelligence I have taken, how the bird is flying through this, the condition of the bird is flying over the that is particle sum optimization. Through the particle option, very quickly you can detect what is the fault detection in it of mechanical system you have developed it. So this is the conclusion. By reactive maintenance, we intelligently we can maintain the things. So this is also another project I am having. Okay. So another project also I am having sponsored by IIT Guwahati by taking the picture of the underwater robot. We have to analyze the image, what is the condition of the any type of dams, because there is 130 dams inside the Odisha, and we analyze what is the condition of the east dam inside. That is another project. Also, in our, this is the proposal project in IIT Guwahati. Also, my research project, whatever things I have already uploaded by the Doordarshan 6 in Odia channel, and they have developed in Odia and Jnana Vigyan, that is very popular in Odisha. That is telecast in 2 o'clock at Sunday and Tuesday at 10 o'clock for all the schools in Odisha to develop the scientific temperament of the school students. So this is my few other things also in Odia. This is a career calling. Then another is vibration. Then this is about the solid waste management. Then smart materials, also robot, artificial intelligence. So many programs I have done in Doordarshan 6. It is quite popular in official channel of the Doordarshan 6, including my own YouTube channel. Thank you so much.
Thank you. Thank you, Dr. Ravi. Now I would like to call candidate E3, Dr. Sukanya.
Good evening all. I am Sukanya. I am a postdoctoral fellow from IIT Gandhinagar. So I would like to introduce a smart energy system called Shakti, smart hydrogen-based advanced controller for transitioning to indigenous green energy, which transform intermittent renewable energy into reliable continuous power by integrating different energy sources and storage system. Why it is needed? India receive abundant solar energy. Even after sunset, we are relying on diesel generators. It's not because of the lack of availability of energy, it's just because of the lack of a real and smart storage system which manage and deliver power when it is needed. So our solution is Shakti, which contains a universal power converter which integrates different types of sources as well as energy storage systems such as solar, battery, AC grid, hydrogen fuel cell, and electrolyzer and loads, along with a smart energy management system and advanced control. And we have developed a 3 kilowatt prototype of this. This is just like an intelligent traffic controller. Whenever abundant solar energy is available, it is given to the load as well as it's stored in battery as well as in the form of hydrogen by using electrolyzer. When sunset, this stored energy is used for powering the load. So this can be utilized for various applications such as rural microgrid, EV charging, long endurance UAV, grid energy storage system. So I conclude my presentation with a quote like the future is not only about generating more energy, it's also about managing energy intelligently. Thank you.
Thank you, Dr. Sukanya.
Forward, backward point.
You need to download. No.
What do you want? Yeah, you can go with this then.
Yeah. So, good evening, one and all. Today is 14th August. Tomorrow we celebrate Independence Day. In 1947, Punjab received independence and partition, both. So here we are presenting like what happened after partition happened. Like if you suddenly cut a major hub out of the culture, so what happens to that culture? So the culture lives, or it takes shapes of the region, and what happens to the language system there, the literary systems there. This presentation is basically about that. So culture lives in relationship rather than in places. How do we actually absorb those relationships? And we have proposed a method by reading the books, by analyzing the catalogs and the literary systems there. So what kind of books they were reading, and then the partition happened, and those system of publishing industry got scattered. And why did that scattered? Was because of the bloodshed, or the publishers were moving to the margins. Because the center that was Lahore and Amritsar was totally dismantled. Sorry for the presentation, I go on with this. So once Lahore was dismantled, the basic center of publishing hub in India got scattered. And afterwards, the Jalandhar and Patiala rose in the post-partition period. So the question here is, what as in culture disrupts when there is a big right systems and also there is a fragmentation? And the answer is culture survives.
because culture is made through relationships, through peoples, and through the daily life activities that people go through. So thank you for the... And this is something that culture doesn't disappear when a place is lost. It relocates and it reorganizes. So perhaps the real question is not what we lost in 1947, but what has survived and what we are preserving now. Thank you so much, and wish you Independence Day in advance.
Thank you, Anima. Now I would like to call our last presenter, Dr. Suresh.
Good afternoon. This is Dr. Suresh from ICR NAM, a think tank scientist. Oh, how about farming fish in the sea? You know, we have exported 73,000 crores last year, and we are targeting to double the fish production and export. So it is sustainable and also more remunerative for economic growth. And it is the biggest component in the blue economy, which is being now Honorable Prime Minister is thrusting upon. Yeah, you can see feeding 8 billion people, and the food will come from water. That is the projection by several agencies. So we have about 71% of oceans, and hardly we are using 1%. So farming in the sea always exciting because it needs technology, it needs and more technical knowledge imparting to the stakeholders, first of all, but it is very, very challenging. So we have many institutions who are doing a lot of innovations in technologies, and also there are seed production for marine fish, and also national policies which are supporting by the government of India. But there are very scattered, and also it is never been integrated. So there is a missing link which required urgent need for addressing this for a solution. So we design spatial intelligence decision support model, and also which is integrated with techno-economic intelligence, and also completely a integrated mariculture data cube. That will be first of its innovation in India, and in the world nobody has integrated geospatial intelligence and also techno-economic models, and also decision intelligence, how the fish need to be farmed. So this is the engine, fusion intelligence engine. This will deliver to the farmer, entrepreneur, and policymaker in a single go. So it can be expanded to future to other agriculture sectors also. Thank you. Towards Vikasit Bharat.
Thank you, Dr. Suresh. And here we conclude our 2-minute talk presentations. For further announcements, I would like to Dr. Srikanth. I would like to request Amrit and Anshuman, can we take over?
Hello. So thank you everybody for trying your best to borrow some of the aspects of the playbook and relook at your own explanation and working on it. I'm sure you would have noticed that it's one thing to read items like don't bury the lead and prioritize, but when you actually start doing it, it's not that straightforward. You would have also noticed that asking ChatGPT gives not so great results, at least if you ask it only once or twice. So this is going to be a long-term exercise for each of you. Whenever you need to be in a room with an audience who is not your peer, you are forced to, I wouldn't say dumb it down, but forced to tweak your explanation for the room. It is going to benefit you. Your students, for example, the BTech first year students will benefit if they know what you are doing, but because they are first year bachelors, they will never understand all these technologies and terms and etc. So what you have learned today will be useful. we noted down, we didn't want everybody to rate each other, to not make it like some Indian Idol. That was, we got some feedback if everybody could give a feedback to each other. But that means everybody has to focus deeply on each other's presentation, and that would have been an extra task. But individually, we will pass on what we thought about what you did. I'm sure that wherever you were in the morning, hopefully there is something that each of you can carry by now. This output is a way to actually practice. Doesn't mean that what you have done is the final output. Hopefully you will keep thinking about some of these things, is how we would like to conclude, and I'll just pass on to Anshuman if he has some words to share.
Yeah, Amrit pretty much covered all of it. One thing actually I wanted to ask a couple of people, what did you understand by don't bury the lead? Because that is something we felt almost everyone missed. So would someone like to volunteer and tell what they understood by don't bury the lead? Anyone? Lead should come often throughout the presentation.
Upfront.
Okay, anyone else? Yes, please. Define the question in the beginning. Okay? Putting the solution in the beginning. Okay? No. So the idea behind don't bury the lead is, if someone stops listening after that first 1 or 2 lines, do they still understand what's the gist of the paper? Like, what's the main finding of the paper? What's the main outcome of the paper? So some of you said, like you said the solution, you said the question, but it would be like question and the answer both maybe.
So the lead has to be so short that it's memorable. If you take a paragraph, again, best is to look at any day's newspaper. Newspaper title is what we call a lead in journalism. Because often everybody is skimming, right? So again, in a room like this, people are skimming. They broadly want to know what you have done. They really, and once in a while, they might show more interest if the starting line is great. So the lead could be anything, but as Anshuman said, if you said that one line and stopped, is it enough? If it's not enough, then you have to work on it. And often a lot of you kept it, so lead cannot be technical, lead cannot have jargons, lead has like to be memorable.
Reading a headline like a bus fell in the, off a cliff and a few people died, versus today I am going to talk about an automobile failure. The topic of my news is that sometimes automobiles don't go as they are planned and they fall off the track. That doesn't tell me, like if I just read that one line, I get what is being talked about in this. Whether I listen or not listen, whether I want to go into details or not, that comes later.
Anyway, so let's not make it about assessment at this point of time. As I said, it's a workshop. You get so much of time. Thankfully, everybody has something in their mind. We will probably through WhatsApp. There's a more detailed playbook, right? This is a never-ending skill. We could have shown you 20 different frameworks. We didn't want to do that. Idea is that even one single thing, just don't bury the lead, could have been a whole day, and yet you would have tried to improve and improve and improve. So everybody will take their own journey.
This is one more point I want to talk about. The slides. So I think a lot of you used the slides you already had, right? I could see that, like very well arranged graphics, images, text, and everything. It would have, so it might make sense to show so much of details if you are presenting for, let's say, 15 minutes or 20 minutes. If you know that you have 2 minutes, it's better to start with 3 blank slides, close your eyes, think about the 3 main points you want to talk about, and just type those out on those 3 slides. That's much better than more number of slides, more information in each slide, so many images in each of the slides. Just top 3 ideas, close your eyes, think of them, put them on blank slides, and talk about it. That would be much better in a 2-minute presentation.
We call it the 0 say 1 approach than the 10 to 1. So most of you were looking at something which is 10 and trying to bring it to 1. That's a lost battle. Because if you look at everything, then it's obviously difficult to figure out what to keep. So everybody kept everything and then said, we will come here and say something. You can know that it's not going to be effective. So 0 to 1 means forget about everything. Again, AI is helpful also there, but also little waste there, because you have fed everything, it is going to create everything for you. At the same time, you could just ask the same AI tool, which some of you used to create those infographics, that limit it to 50 words, limit it to one visual. You could challenge the same AI tool to actually help you with much cleaner slides and stuff. The only issue is the AI will ask you, what do I remove? So it will eventually go back to you. At some point, you will have to say, okay, let me take a deep breath and realize of all these 10 things, which one am I okay to let go of? It's almost one of those questions that a parent gets asked, who is your favorite child, right? So it's become similar with your own research. So I can tell you it's hard, but the audience only wants to meet one of your children, so you can't do much. So you have to just pick one, whoever you think is, whatever, going to dance best in front of you, the crowd. So that's an analogy I'm giving in that. It's hard, and therefore should not be done all the time. Do it only for that audience, who in any case is not going to really. So we had said this in the beginning. You saw the bad presentation done, and it's easy to do it for some other research, which also I hope everybody saw. When it was a neutral Earth research, everybody easily removed points and made it simpler. The moment it came to your own research, all of you had so much emotional connection to it that you said less, but you still wanted everybody to see it. This is a cultural change, will take time, and we hope this is a right step in that journey is what we hope. So thank you again so much, and over to Shrikant for concluding the session.
Thank you, everyone.
So thank you both, Amrit and Anshuman. It was a wonderful marathon session, but at the same time it was quite interesting to see the lessons that have been carried over in just one day. So this was a very intensive workshop. All of you have really put in all your cognitive efforts into doing this, and I could also see the changes in the presentations, because I looked at almost every video. There were some videos which I didn't understand in the webinar showcase, but now I see that the narrative has changed. The way that you're approaching the flow of the presentation, the flow of the technical content also has changed. And you're also now, I'm seeing that you're also paying attention to the audience. You're keeping that in mind. So that is a win, I would say. And doing that in one day is really tremendous. So thank you very much, Amrit. Thank you, Anshuman. Thank you all. And before we move towards the formal closing of the session, what I would like to do is I would like to invite PK. He has a few words to share with us, and I think he also wants to talk with us. But again, thank you. Thank you, Amrit. Thank you, Anshuman. Thanks a lot. Yep.
Good evening. Good evening. Abhi to we have to go home now, no? How many of you are leaving today? How many of you are leaving tomorrow? How many of you are continuing to stay here for next 1 month? If I allow, they have to allow. I also have to leave from here, no? He's saying after 1 month. Yeah, very good. Good, yeah, good. Thank you. No, I don't have anything to say. I only have to ask some things. First, let's do a thank you note. I'm sure he will do his part of thank you notes, formal ones. But the unofficial ones, let me do. First, when I say your name, if you can get up, that will be really nice. First, let's do Shyam, Shrikant. Shrikant went away? Yeah, please stand, Shyam. I think, thank you. Thank you for Sanjeev also, sorry. Yeah, I thought one by one I'll call. Shrikant, please, everybody's thanking you. So it's, right? Yeah, so that is a separate one. So yeah, please come. I think nobody knows you, but we have to bring in front of everyone. You should be here. Any guess on who is he? No? He's a student, okay. Great guess. Next better guess. PhD student of them? Oh, they all have a lot more PhD students. He created this content. Very good. Nice. Thanks. So he's the one responsible for doing everything. When I was talking to him during lunch, I said that I need to meet him. Before also I've said, but I said I need to meet him. Thank you, Yaar. Thank you very much. Thank you very much for doing everything for us. So yeah, so you should.
No, go for it. All of us together.
Yeah, come. Thanks for doing everything at 3 a.m. in the morning. Srikanth was telling me that he was doing everything at 3 a.m. in the morning, but he was very brilliant, I think. Okay, that's the first set of. Can we get the students who helped us for the, please get up. You only are. Comparing, I think I see people there, no? Please get up. Students, whoever helped. I saw some, but back end, you know all of them. Back end, whoever helped. Let's give a round of applause for all of them. I think it's very hard to do these kind of activities. How many of you have done these kind of activities in your own roles? Campuses, well, yeah, I'm sure you understand, right? Everything, nothing will work sometimes. You saw morning Srikanth, Wi-Fi nahi chalta, right? So I was telling him during lunch, in the playbook, write down saying that Wi-Fi should work, right? So all of us should create all these kinds of playbooks for doing. Thank you for helping. Please sit down. Yeah, okay. And of course, aap log wagera bhi, thank them. The IT support, I think it's hard to do these kind of things for these activities. Now let's give a big round of applause for all of us, participants. Without you, I think we can't. So one of our sincere hope is that we had 122 submissions this time. The next summer 2027, there's going to be an edition. There's going to be an edition in between. We still don't know what that edition will be. But there's going to be definitely an edition in summer 2027. That edition, we are hoping we'll get 1,000 videos. At least that's the aspiration. Because that's why yesterday also I said, please post on social, do some FOMO, get others to, and then when you posted, I saw others commenting on it, liking on it, all that. Let's create a little bit of a buzz around, look, this is, again, Amrit also repeated, Shubham also repeated, Dr. Shiv also said, let's not think of this as a publicity. Whoever is talking to you also try to tell them, right? Look, yeah, I think there are going to be people who may think that is publicity. It's okay, right? Let's move on. Yeah, thanks to all of you. But now let's thank both of them for your efforts. I know Amrit and I had called some few months back, and then we talked. And we said, okay, we should try something. I'm super happy that it's come at this point. They have access to all the playbooks, no? You said there's a longer version, shorter version. They have access to something. Yeah. So if you, I'll do a post tonight. So if you send me the link, I'll put the link in my post also, right? So I've already composed my post. So you should just give me the link. So yeah. So that's those are from my side, of course. Now let me ask you some questions. Any thoughts on how to make it better? Formal feedback, Srikanth will send a form, you do all that, but this is for me to take, this is for me to pass it to Dr. Shiv quickly. Look, this is what happened, this is what it is. For example, some of the ideas that I can tell you where the number is one thing that we have in mind, but how many of you have seen the page that Srikanth is maintaining, 122 videos, how many views we have? That's also another interesting metric to look at, right? So 100 videos, now it's, I think the last one was 25,000 views, some 300, 400 likes, comments, shares, or whatever. So we would like this to be like 1,000 videos, 100,000 views, 1 million view, right? And clearly, please, you're in the foundational cohort or something like that, if you have to call it at some point. But please keep in mind, we will take this big, which is that these kind of contests. So Amrit and I were talking about this football game. He gave an analogy to a football game, finals. ANRF will do that final thing. We'll create leagues, matches, all of you, 122 of you, some 36 came here. Whether you thought about it or not, some of us were looking at what all you're presenting. Maybe some of you will get an email or a request from us saying that, oh, can you improvise on this and do the submission, send it to us, show up in Delhi, present it to them, show up here, present it to them. All this is coming because we are tracking all the data also. Tracking meaning we are capturing all the data, right? We know where you came from, what you submitted. We can come back to you saying, oh, look, there is an event in, let's take Vellore. There are Vellore faculty, right? There's an event in Vellore that ANRF is participating. Can you go present your work there? Yes, no? That's easy. That's easy for us. For example, even for these kind of events, we sent invites, just that it's hard to get these. How many of you know the J.C. Bose faculty? How many of you know Prime Minister Science Chair? PMC, right? The 3 categories like that. We send, so when we have events like this, to the local professors who are of that category, we send invites saying that, can you come, do a 15-minute session, all that. So that also we are starting. So they will come, you will come from somewhere, the participants are there. So I think we're going to give you more and more visibility. The more you do, the more visibility we'll also give you. Find ways to bring you to people, bring people to you, all that is planned. Okay, so that's one suggestion or thought process. But give me, you should speak. Tell me some feedback. Let's do the ones that we can do better first, because that's the harder one. Okay. Research oriented, but that we'll have to, the host, I think here it's easy because Dean R&D is here. When are you leaving? Tomorrow. So otherwise, we can see whether, how many of you will be interested, but tomorrow is a holiday. Yeah. Okay, so that's a fair point. That's a fair point. So, so a tour of local host. Is that okay? Okay. What else?
Can I speak?
Yeah.
That people can really interact.
Okay.
They can also look how. Yeah, thank you. They can also interact each other. Maybe the interactive classrooms.
Okay.
That would be really good.
And
so one small thing. Another thing is that when you prepare next time, you can also bring an app, because you people are very good in storytelling. Why don't you do a storytell for this thing also? So everyone knows what is what.
Storytelling meaning what?
Of the participants, everything in the beginning itself. So we know what is what. They have given the list of the names and other things. This can be little more.
But what, Srikant, I don't understand. They have to. No, just say what is the feedback? I don't understand.
Yeah. So because we have collected a lot of information about the participants, we already know the kind of research that they do.
Yeah.
And the list of participants was actually shared fairly late. Well, not exactly late, but just at the beginning of the program.
Yeah.
So they felt, what sir is saying, that we can have this in the form of stories, what kind of research everybody does.
Okay.
We had that in mind. Actually, Shankadeep was again working late. Shankadeep is here.
That's okay.
He was trying something with an open AlexNet or something, didn't work.
Okay, share participant details.
I think we can do it later also. We can still do it. We can think about that. But
I'm
not
I'm super environmental. No, I don't even wear the tags they give me. It's a conscious choice.
No, we can make it as a digital book.
Yeah. If you do soft copy, I think it's okay. Okay, very good. So the feedback I wrote, a tour of a local research labs, smaller interactive rooms, share participants' details beforehand. Okay, go on. Yeah, just speak. Yeah. Sure. So industry to be invited. Yeah. But the problem, the discussion that we had is that where will you fit? Meaning we'll have to. So because if you look at what ANRF role currently is, what's your name? Shubho. Shubho. The ANRF role, Shubho, is only to orchestrate it. We are not getting involved even in the program. Srikant and Sham owned the program. So I think I can put this in the playbook, but the program owners are not us. Because that's something we don't want to, we want to just. So there are few things that we would like to make sure that the program has, which is Dr. Shiv's session. There should be a session on how to write better proposals. These are suggestions that we talked about. Those are the things that we would like to, for example, this JC BO, CAO, all that. Industry, we can give them the guideline saying that please try. If it's there, it works, it works. Yeah, fair point. I think you told me the industry thing yesterday also. Yeah. Go ahead, whoever,
okay,
just get up and speak. Just get up and speak.
No, I think my point is more about creating the next generation of STEM leaders, basically more focused on students. So imagine that we had an 8 minutes presentation. Could it be that we can incorporate, because each of us have such diverse, we're from such diverse fields and we have had like great journeys.
Okay.
So those kind of stories also motivate youngsters that, oh, this person could do it coming from this village or this town and made it to say Caltech, MIT, and came back and served the nation. I think if a minute or two could be incorporated in the beginning, not just talk about your project, but about your story in your initial presentation, I mean, that might be inspiring.
In the submission, you mean?
Yeah, so it might be inspiring for youngsters. Yeah.
Sure, so we can add that, but I would have said you could have done otherwise also. We did not say what you should speak, no? We said you should speak research.
Because generally we don't.
Yeah,
we will just talk about a project.
Yeah. Have you listened to the lightning talks, ANRF lightning talks?
Yes.
How many of you listen to ANRF lightning talks? How many of you know about it? How many of you don't know about it? Yeah, okay. So this is basically, if you remember, research impact, XXXXX, right? And that one of it is called research impact, lightning talks, in which we force the speaker. So this is about 12 minutes talk that the researcher grantee gives. 12 minutes into 3, for example, whoever is interested, 19th of August at 11 a.m., it's the next lightning talk. It's a Teams call that you'll have to join. ANRF hosts it. 3 speakers across the country will come in one discipline every time. They speak for 12 minutes. We force the structure there, which is first slide should be who you are. Last slide should be contacts of you, LinkedIn profile, your email address, how a student should be able to reach to you, and things like that. That's the last slide. So we kind of gave, that's a 12 minutes. So we said in the playbook for the contest also we can write that.
Sir, a concern on the faculty members. So many of the participants are from faculty background.
Yeah.
So if these kind of events can conducted during the semester holidays, can be odd or even semester, that is even semester holidays comes on November or December, and the odd semester holidays comes on May month, June month. So that will be better, like getting permission.
Absolutely better, but we won't have organizers. No, they also want break. No?
Yes.
I mean, just now I said, right, the next, not the next, one of the future editions we know is because they committed. We've been talking to a few people for December edition of the contest. Nobody wants to do it because it's a break, which is, I think, is a fair point. I mean, there are even other reasons that I would want to do it in summer. No, today we were able to do only 50. Because that's a guest house restriction. It's not a restriction of the platform. I mean, if he gave a comment, no, do it in smaller room. The reason why they've got this bigger room is that we envision that there will be more people also, right? So 50 is the, understood, the architecture of the room. Understood. Fair point. So that's the reason, right? Summer, December, it's just hard for anybody to do it.
So my suggestion is we can plan of conclaves specifically for regional languages in that region, where we can have some people, writers in that language also participating. So that can improve. We can also encourage more people to do in their local languages.
Sure. I think this one, these kind of inputs, if you gave, my immediate response to do is take the ownership, do it in your institute. We will be part of it.
Sure.
We want also to take responsibility, right? It's not, it's not that ANRF is going to. That's why I clearly said we're only orchestrators.
Sure, we will do.
Yes, ma'am.
Since we are all actually, thank you. We are all focusing on improving the overall from the basic level up to the higher level. We are trying to improve. But we are holding these all these conclaves in institutes which are already very highly reputed or which are already have their expertise. So bringing all together here at these venues, which are already every one of us are expertise in our own field. But can we take both these expertise to a school or college level, where from we want new generation of people or youngsters, they can look up to us through our research and through our expertise.
Yeah.
I think
Absolutely.
the common venue, maybe the next conclave, if you can hold it in some +2 colleges or undergraduate colleges, where they can see the overall scenario of the science.
Absolutely. Meaning, again, you tell us the proposal, you tell us that it can be done here, you take
Yeah.
responsibility in running it, we will bring.
Definitely.
So please keep in mind, currently all the locations that you're seeing is not because we wanted to go there.
Okay.
Clearly, even here, there was some discussion saying that, oh, we should do this, here are some ideas. They took it up. Please keep in mind, I don't think so. I am part of any discussion with them saying that, oh, we want to do it. It's some discussion. I think Dr. Shiv was here. He mentioned to them saying that, oh, these things we're planning. Oh, they said, okay, we'll be excited, and then we got connected.
Fine.
If you are saying that you want to take it to an institute, so I think from the last 2 days, I mentioned to 1 or 2 of you saying, run it in your institute. I told probably you also. You take you take the ownership, we'll come to you.
Yeah, thank you so much.
Anything else? Yeah.
Who is the project title will be there? Who is the PI?
It's already there. It's there. It's already there. It's called PRISM. Just search for ANRF PRISM.
PRISM, okay. It's there already. SCRB.
So
okay.
it has a project title, who's the PI, email address, abstract. It has all of that. So the video one of the videos that I showed you, actually one of the videos that Lakshman showed is actually generated from that abstract.
Okay. Thank you, sir.
Okay. If nothing else, thanks for coming, and hopefully please be active, please be, so to say, I think I used the word orchestration now. Let me repeat that in a different way, 2 words that you will keep hearing from ANRF for some time, is we would like to be, generally all of us think that ANRF is a funding agency, which is what it is. The primary job is to fund research, all that. But we would also like to have 2 other words added to the portfolio of ANRF, which is we are an ecosystem builder, we are a catalyst. All this is in the efforts to have that perception of ANRF. Because you came together, you probably made some connections here, hopefully you'll write a proposal together, hopefully your slides got better, hopefully you'll do a better presentation, hopefully things will fall in a direction. I think Amrit also said this is starting. Okay, thank you.
So I'll just take the last few minutes to formally close these sessions. This is the first time I organized a conclave, and this is the first time I'm doing a formal closing session. So I hope, please to excuse if I make some mistakes. This is the first time and not prepared anything. But for sure, the first people I would like to thank is all of you, because you took the effort, you waited for us to get back to you, then you also took the effort to come all the way here, spent 2 days with us, had a good time, we also interacted, and I really appreciate the time that we all spent together, and I really hope something good comes out of it. So thank you very much, first of all of you, for coming here and participating in this event. Thank you. The second thing, for me, it is always students, because the students, if they do not participate, then all of this stops. So because the students participated in this event unflinchingly, without any reservations, without like, "Arey sir, nahi ho payega," never heard that. From the batch of students who helped in developing this putting together this conclave, never once did I heard, "Sir, nahi ho payega." It was all like, "Dekh lenge sir, kar lenge sir." So to the students, I really thank you a lot. You have been the backbone of organizing this. Please keep it up and pass on this culture so that your students also do it, right? This is very important. Okay. I would like to also thank all my co-committee members, because I now realize the power of the committee. Yes, we have been planning for several months now. Well, not several months, but yes, at least 2 months. But at the execution stage, it becomes very difficult. It kind of spreads very fast. And at that point in time, when the committee comes together, and if our senior committee member is also sitting here, Professor Ajay is sitting here. And Professor Ajay, I said, "Sir, aise kar sakte hain, aise kar sakte hain." He said, he just picked up the phone, called. I said, "Mere ko de diya hai na, tension kahe ko le rahe ho? Bhul jao sab." And literally, I forgot everything. I said, "Sir, aap le liya, no problem." So I really thank all the committee chairs, not only Professor, of course he has been he's also a mentor of sorts for me. And I really thank everyone, all the committee members. And I then come to the closest committee members, who are Sanjeev and Shyam. Given that I'm doing this for the first time, they have been holding my hand since day one, telling me, okay, aise mat karo, aise karo, aise mat karo, aise karo, because I'll have all these outlandish ideas, they'll kind of, nahi ho payega, pull it back. So that has been very helpful, and Sanjeev is extremely busy. He was already organizing 2 conferences, and on top of that, he took on the load of mine. He said, okay, no worries, I'll also help you. So thank you, Sanjeev, thanks a lot. Thank you, Shyam. It has been very, if I start talking, then it will go on and on and on. But what I would say is, again, wonderful mentoring. Thank you so much. I learned a lot, and I'll keep learning. Thank you. And finally, I would like to thank ANRF, PK, Lakshmanan, Aparna, everybody from ANRF who helped make this possible and gave us an opportunity to show what we can do and what can be done and how we can help in our very own small way to make India or show India as a strong scientific superpower. That has always been my objective, that we are doing some great stuff here. It's just that we are not beating our drum about it. This is the start of that drum. And tomorrow is Independence Day, so I think that's a very good start for us. So thank you all. Thank you for coming, and I really appreciate what you have been doing so far. Thank you. Thank you. What is it? Do we have the schedule? Thank you. Yeah, we'll also share an online feedback form. You can give some.